Today, we'd like to show you the future of Next.js. But first, we have to go back to the start. When we created Next.js in 2016, it was a server-rendered framework for building React applications. Over time, we added tools like automatic static optimization to help developers achieve a consistently fast experience whenever possible. Next, we became the first hybrid framework, adding support for static site generation. Then, we added incremental static regeneration, helping you scale static with faster builds and the ability to fetch new content without a rebuild. Developers could choose on a page-by-page basis which strategy worked best for their requirements. We tried not to be dogmatic about a single solution and instead empowered developers with flexibility. What we found, though, was that speed and personalization were often at odds. Server-side rendering allowed us to personalize content for our users by computing the HTML on the server for each request. However, it was difficult to have consistent performance and reliability guarantees. Static site generation allowed us to consistently serve fast content by caching files at CDN edges around the world close to our users. However, we lost the ability to modify the HTML based on the user's request. We can make content more static to solve speed, or we can make content more dynamic to solve personalization. The challenge is to do both at the same time. What if we could have the power of dynamic at the speed of static? Our solution is to embrace the edge. But what is the edge? Like CDNs, the edge sits between origin servers and our users. But unlike CDNs that store static content only, edge servers can both store and process data. Let's hear from Suzanne about how we're addressing this challenge.
Today, we're introducing middleware in Next.js and edge functions on Vercel. Middleware enables you to use code over configuration. This gives you full flexibility in Next.js because you can run code before a request is completed. Based on the user's incoming request, you can modify the response by rewriting, redirecting, adding headers, or even streaming HTML. This works out of the box using Next Start or deployed as an edge function on Vercel. Edge functions let you run code close to your users. They use a strict runtime that supports standard web APIs like fetch. This runtime is built on V8, an open source and high-performance JavaScript and WebAssembly engine. Using V8 provides 100 times faster startups than Node.js on virtual machines or containers. That means there are no cold starts, ever. Middleware can be used for anything that shares logic for a set of pages. Authentication, bot protection, redirects, handling unsupported browsers, feature flags, A/B tests, server-side analytics, logging, and more. When self-hosted, middleware works out of the box by conforming to the standard Next build output. Any hosting provider can be configured to support middleware at the edge, and Vercel supports this new runtime for all users today. When using Next.js on Vercel, these edge functions are deployed globally by default. As a developer, you don't need to worry about configuring infrastructure, and Vercel automatically optimizes your Next.js application for the best performance. First, let's look at our base case, a static commerce item with no personalization. This page loads quickly, and if I open up my VPN and change to another region across the world, it still loads fast. This is because our static assets like HTML, CSS, and JavaScript are cached at every edge on Vercel. Now, let's try the same thing with a dynamic internationalized commerce page. Based on the user's location, it offers a discount on the price of the mug. This still felt really fast because our logic for determining the user's location and returning the discounted price is deployed in US East. If we switch back to Japan, you'll notice it's significantly slower. Why is that? While our static example was cached and immediate, Our dynamic, personalized example had to query data from our origin server in a single region, US East. Due to cost or complexity, teams often don't set up a multi-region deployment for their data layer. This puts speed and personalization at odds. We can make content static to solve speed, or we can make content dynamic to solve personalization. Using middleware deployed as an edge function to Vercel, we can have dynamic at the speed of static. Let's take a look at the code. We can define a middleware using _middleware inside the pages folder. Since this middleware is underneath the /edge folder, it will run before all requests to /edge. This function looks at a user's location and then rewrites the request to /edge / their country code. Let's try it out. After I turn on the VPN, we can navigate to /edge in Japan. It's instant. But notice the URL didn't change. Under the hood, our middleware is rewriting this request to /edge /jp, which has been cached at the edge, giving us high performance personalization with no delay or layout shift.
What Suzanne just showed us lays the foundation for the future of React and Next.js. At React Conf 2017, Guillermo showed Next.js to the world with a Hacker News clone. This demo showed the ability to server-side render React applications with zero configuration. I'm excited to share we've rebuilt that demo to use React Server Components. React Server Components allow us to render everything, including the components themselves, on the server. This is fundamentally different from server-side rendering, where you're pre-generating HTML on the server. With server components, there's zero client-side JavaScript needed, making page rendering much faster. This improves the user experience of your application, pairing the best parts of server rendering with client-side interactivity. We've been working with the React team at Facebook to prepare Next.js for React 18, server-side streaming, and React Server Components. Let's take a look at the updated Hacker News clone. On the left, I have the client-side rendered version of our Hacker News clone. On the right, I have the React Server Components version. I'll use a Chrome extension to reload both tabs at the same time. On fast network speeds, you'll notice they load about the same, but not all our users have the same device and internet speeds as developers. Let's simulate a throttled network speed and compare the results again. If we reload both examples, you'll notice that the server components version renders instantly. This is because we moved computation from the user's device to the server, whether it's my local dev server or the edge. What if the API itself is slow and not the user's device? If we look at a completely server-rendered example, you'll notice we see a browser loading spinner and a blank white page while we wait for results from the server. It's either all your HTML or nothing. With server components, you can stream HTML from an edge function immediately and progressively show updates as your data comes in. Next.js now enables you to do data fetching at the component level, all expressed as JSX. Using React Server Components, we can simplify things. Special functions like getStaticProps and getServerSide props are no longer needed, and this feature aligns with the React hooks model of co-locating your data fetching with your components. You can rename any Next.js page to .server.js to use a server component. Then you can also use client components which hydrate and become interactive, allowing you to add client-side functionality like upvotes. React Server Components are ready to try today under an experimental flag inside Next.js. This removes the choice of static or dynamic and improves your core web vitals by serving minimal or no JavaScript to your users. Server components give developers a new choice on where components render, either the client or the server. This enables the future of Next.js to give us one more thing. What if we could have all the benefits of incremental static regeneration at the per component level? This would remove the choice of all or nothing page caching and enable granular caching at the component level. We're exploring a data component which works like a React suspense boundary. This allows you to add properties like fallback, revalidate, and even surrogate keys, defining your caching semantics at the component level. So if we revisit our slow server rendered example from before and use the data component, we can instantly see a static cached result of our data, even if the API is slow. Then we can use the revalidate prop to clear our cache and fetch new data, similar to the model that we've established with ISR. React Server Components and granular component caching are made possible by innovations like edge functions that support streaming, eliminate cold boots, and deploy globally by default. We think the future is at the edge. We want every developer to enjoy access to the best infrastructure for all their projects. Today, we're making edge functions available for all Vercel users. With edge functions, we're giving you the power of dynamic with the speed you expect from static. Middleware gives you back the flexibility you had with servers while allowing you to push code to the edge of our network. Get started for free today at vercel.com/edge. Finally, Next.js 12 brings us the future of React. With server components, you're able to combine static and dynamic data fetching, allowing you to render pages at the edge close to your users. Upgrade to Next.js 12 today to try it out.
Hi, my name is Steve Sewell, and I'm going to talk to you today about high-speed edge personalization with Next.js. I'm incredibly excited to talk to you about this because we will be mostly covering the Next.js team's latest announcement just from today, Edge Middleware. We're going to talk about what problems this solves, how to use it with interesting personalization tooling, and a whole lot of other exciting content. Let's just go ahead and dive in. First, who am I? I'm the founder and CEO of a company called Builder.io. We're a headless, no-code platform optimized for Next.js. Plug us into your Next.js site and let your non-developers create the pages and personalized variations that they wanted while making sure that it meets your expectations, uses your design system, and is high performance all the time, leaving you without needing to work on this huge backlog of simple requests for pages and tests. But let's jump in a little deeper into what we're going to talk about here. So first, I want to briefly cover how is personalization implemented in the past. What are the things that went well and what did we learn from that we're going to improve upon? Then what are current common patterns for personalizing with Next.js and what are the trade-offs? Then we're going to talk about personalizing Next.js with Edge middleware and then integrating tooling because you probably don't want to hard code all the personalizations. You want to hand off a good set of tools to be able to handle a lot of this for you so your non-technical teams can create the tests within your guidelines and then you can not have to worry about the details. So let's talk about the problem that we're addressing here in the first place. Traditional solutions to personalization are slow. So in the past, you'd probably send a request to a remote server. You would have to actually send the request around the world. It could take 100, 200 milliseconds just to reach the destination. Then the server will pull a bunch of dynamic data, assemble a page on the fly, and send it back around the world. In a lot of cases, blocking JavaScript would then prevent the page from being visible, pulling in personalizations or other information, and then you end up with your page. Now that's quite slow. We want to have fast pages that are immediately visible and personalized. And so what we really want is static generation, right? It's fast, but everybody sees the same content. Your homepage is the same page for everyone. And how a lot of people trying to address this with Next.js currently is they will load placeholders or empty boxes that then will pull client-side some slightly more personalized information, like the amount of items in your cart, or maybe some more specific personalized products or other things of that nature. So let's look at this in a diagram form. So what we don't want is this. We don't want round trips to an origin server, fetching and rendering personalized data on the fly, and then sending blocking JavaScripts that might add additional content injections that are unique to the visitor that ultimately are going to give you very poor mobile speed. I'm estimating 1 second for this, but that's being generous in a lot of cases. We've seen much, much worse in the field. What we want instead is a cached response. We want it locally, so from the edge, an edge network, so it's physically very close. There's almost no travel time between the edge server and your visitor. And we want it cached. We want it to be immediately available. So the response time is 10 milliseconds, no blocking JavaScript. You just get your personalized page without any other hiccups or problems in the way. Now the question then is, how do you do that? Because before today, this was not a very straightforward process. So let's talk about the solution, how you can actually get the best of all worlds with this latest feature and integrate with other tools. So first, what do we want? We want high-speed optimization with edge middleware. We want, when somebody visits the homepage of our website, we want different audiences to see different content. For example, if somebody only shops men's collections, let's show more products from men's collections. Same with for women. If they're a return visitor, maybe we can show a special deal to them. We don't want this stuff using blocking JavaScript, server-side rendering, or all kinds of other issues like lazy loading purely in the browser. We want to immediately hit our audience with personalized content, because if we're showing everybody the same content all the time, it's not going to be optimized for anybody. There's no point showing irrelevant products, irrelevant content, irrelevant things. And traditionally, there's always been this trade-off. We sometimes call it the conversion paradox. You start introducing more tools, more lazy loading, all this stuff to try and drive an increase in conversions, an increase of things that you hope lead to the behavior from your users or visitors that you want. And in doing so, you shoot yourself in the foot, because you ruin the performance, you add all this additional dependencies, and suddenly you actually made the experience worse for everyone. That's where edge middleware is such an incredible solution. You can integrate in less than 10 lines of code to create simple, synchronous, fast rewrites. You can use integrations such as with Builder, our personalization utilities. You can add, with just a few lines, amazing power for anybody on your team to create personalized variations of pages using your components, your tech stack, all of that good stuff. It is so simple and powerful. So how does this work? So under the hood, this is what we're doing. The edge middleware is rewriting requests. So if we see a URL, we see somebody coming into your homepage or an about page, we're going to look at the cookies and say, is there other personalized information we know? You can set these cookies, or our SDKs can. It's completely up to you. But we're going to rewrite that, say, /about page to add a delimiter like a semicolon, and then add key value pairs. Like, actually, the path for this page is not just about. I want to show the about page for return user equals true, maybe shops collections equals men, other things like prior shopping history, UTM params, all of that can become part of the new path that becomes the cache key. The secret sauce here is Next.js's incremental static regeneration, using the fallback true option, so that if anything comes in and they say, hey, we haven't seen this combination of parameters for the about page path, we can then go and fetch that. And we can decode that very easily using just another utility Builder provides, or any of your own systems that you need. And then you can say, hey, CMS, hey, Builder, hey, any other app and service, do you have a special version for return users, for men's shoppers, for whatever it might be? And then that goes right back up and caches at the edge. So the vast majority of requests, 99.99, whatever it is, are going to get instant fast cache responses because of the static generation that happens in real time. And only an extreme minority of people doing, visiting with a unique combination of parameters will go through the full circle. So let's talk about the ideal stack here for this nimble, personalized content development. So how does Builder, for instance, fit? The beauty of Builder is it's not a re-platform. It can connect to whatever you have. It slides in for your hosting platform. Vercel already supports beautifully edge middleware, ISR, all that good stuff. Your choice of framework, Next.js, is our strong recommendation for all new users of Builder or existing. And then connects to all of your other apps and services on the back end, whether you're using commerce platforms, CMS tools, it doesn't matter. All of them can plug in. Obviously, they're connected to your site, and Builder can be connected in there as well. What this allows is dragging and dropping with your React components. So no more hard coding pages. Maybe this page today looks good with the hero on top and a couple columns, but maybe tomorrow you want a different component on top and you want an additional column. And maybe you don't want to be constantly going back and forth between, your CMS, adding more fields for the homepage and this and that. maybe what you really need in a lot of cases to remove that backlog of requests to throw up a new landing page, to run some tests of a page or small variations, is instead to provide a toolkit to your non-developers to integrate a portion of your site, such as the homepage, parts of other pages, and register a set of components from your design system where you say, hey, you can rearrange these components, input the props, and using a UI, configure personalized tests, A/B tests, etc., all of which will be fast and high performant at the edge, connected beautifully to your React code, and published remotely. So your content can publish and roll back separately from your actual code. So you don't have this interdependency issue where you're deploying code and you're messing with content and vice versa, templates, etc. You get the idea. In practice, this can look like a lot of flavors. Some people really do build their site completely with Builder and Next.js, and it doesn't require a lot of custom coding. Others will work it into an existing site where these blue boxes are. Some pages, like the homepage, may be totally designated, hey, anybody on the team who has the right permissions can make any edits on the homepage they desire. They can add and rearrange from our design system of components. They can run personalized tests like showing different text, images, products, etc. by locale, by shopping history, by any of these things, and just publish and schedule remotely via APIs, and no more having to hard code these templates. You should focus on components, not templates. And then this can be parts of other pages, part of a collection page, part of a cart, part of a product page. We see people will want to personalize product pages based on, hey, if you're on a certain type of product, based on your history, based on the type of product, you might see editorial information about the materials of the shoes being fantastic or why it's a great fit for you as a customer. And all of this applies to data as well. So if you have just pure data like you would in any other headless CMS, in Builder you can also say, hey, I want to show an announcement bar with different text based on the audiences. All of this can be integrated beautifully. It's automatically integrated. It just works great out of the box with the Edge middleware, the entire setup that I described. So every element on a page can be granularly controlled and personalized on a per sort of unit basis. It's very cool. And if that sounds too abstract, hopefully the demo shortly will explain it in better detail. But next, I just want to show how this looks in practice. So the drag and drop editor helps you compose from your components in a high-performant, clean, API-driven way. And then using the UI, you can configure A/B tests, just add test variation, 50-50, 80-20, whatever ratios that you like. And then choose, you can duplicate content or make modifications targeted at various groups. The beauty is this is all statically generated, so this is not what you might be thinking or used to, which is like content injection and other problems for performance, reliability. This is actually in the original version of the page that's generated. You will have content specific to the groups that you define. So you might target by device, by shopping history, by locale or country codes, you name it. It's just a few clicks, run the test, and see how that impacts your metrics that you care about the most. So let's do a demo. Here, I've got this cool little shopaholic site. This is made in Builder, composing a bunch of components in our Next.js repo, images, buttons, all that good stuff. And we have a really cool couple things to show. One, as you should see, is ridiculously fast. We can navigate to other pages, we can navigate back. It's fast because it's statically generated. You already know that. But here's the really fun, awesome part. I have this awesome utility that shows me information, such as, hey, it says I am a return visitor. It says that I am an unknown gender. I don't seem to shop any specific category, or I haven't shopped enough for us to say, hey, maybe you should see more men's versus women's products. Also, you can define anything else, for instance, from a customer data platform like segments, audience such as, hey, you're a loyal shopper, you're a subscriber to our content, you're an ambassador of the brand. All these things we can toggle between and see how it affects the end user experience. For instance, let's see what the men's version of this page looks like. Beautiful. And after it populates, now that's in the cache forever. So anytime I refresh, it's going to just be immediately available. I can navigate to other pages and back, and it's just blazing fast. I can control and right click again and switch to, well, what do people identify as preferring women's products view? There we go. So now we're going to see the women's version of the homepage. As you can see, like always, it's extremely fast. And then we can debug in any which way we want. For example, change the return visitor setting. Maybe we're not going to say we're a return visitor, or maybe we want to just show what do we see for somebody who is in our unknown category. Immediate fast responses from the edge. And then again, this stuff will stick as you move around the session. And now what if you want to make updates? You can just pop over to Builder and see. So here's how we've created several different pages or versions of pages. Let's maybe go to our generic homepage, and you may have noticed that there was nothing special for return visitors. So I can go in here and I can change options, images, text, you name it, all completely customizable on who can edit what and how. But let's go in here and let's make a new version of this page by duplicating it. And let's make this version of the page specific to return visitors. I'll show how easy it is to make the changes that you want and configure who will see this. So first, let's choose who's going to see this. I'm just going to say we want to target this generic version instead to return visitors. Now we can do a combination of things. We can say you're a return visitor and you have various UTM parameters, or we know that you shop a certain collection category like men's. But in our case, we'll keep it simple. Just know that all this stuff is completely customizable to you. Whatever you know about your visitors that you want to set as cookies or in any other way the Edge middleware can read, that can then become something that you target off of with a simple couple-minute configuration. Now, we can go in and let's actually say, hey, let's add some text to the top. And let's say, nice to see you again. We'll be a little bit creepy with it, but you get the idea. And maybe, and this is important to know, you can choose to allow design permissions to some or none of your users, but hey, for me, I know what I'm doing. I'm going to allow myself to have design control so I can edit the UI as I choose. I can add backgrounds, whatever is needed, or use these from a design system of components like a special announcement bar React component where I fill in the props, but you get the idea. I'm going to go ahead and publish this nice to see you again page. And next time I visit, let's do our beautiful return visitor settings. That's true. And gender unknown. Cool. This stuff will be live within seconds. So it uses stale while revalidate caching that you may be familiar with incremental static regeneration. So all I need to do is refresh one more time, and there we go. Nice to see you again. Anytime I visit the site, everything is blazing fast, cached at the edge, and just so easy to create any variation you like. You should no longer, as a developer, need to be telling people no, or there's no time, or I don't have time to code that up. Just hand it over and say, hey, run your tests, look at the metrics, see what's working or what's not, and just give any guide rails you like. Must use your design system, freeform is okay, it's completely up to you. So circling back, just to recap, showed you a little bit about Builder, our headless no-code platform, how you can optimize with Next.js with all of the awesome edge personalization tools. But overall, I want to thank you all for watching this talk. I want to invite you to check out the repo in this link so that you can see that demo yourself and run it yourself. It's really exciting stuff. I would love to see any feedback from anyone. Please, you can tweet, DM me on Twitter. I'm at Steve8708. And I hope you're excited about Edge middleware as I am, because with the right setup, which is only a few lines of code like you saw, and the right tools integrations, it can create such powerful experiences that were just not possible before. Fast, personalized. The dream is finally true. So thanks so much for watching.
Hey everyone, today I'm joined by Kelsey Hightower. He's a developer, author, father, and minimalist. You might know him from the Kubernetes community or his work as a principal engineer at Google. Thanks for joining me today.
Yo, happy to be here.
I'm really excited to dive into edge functions, and I know that you like to explain things based on the fundamentals. So I'm really excited to take a step back, look at those principles, and talk about how they're changing how we build for the web.
Yeah, so for those watching, my background is a backend engineer. I come from a world where you have a three-tier web app, front end, back end, and a database, and maybe a load balancer in between. So getting the taste of all this serverless edge functions and how the web front end is evolving is super interesting to me. So I'm looking forward to breaking down those fundamentals.
Awesome. Well, to kick things off, I would love to just talk conceptually about why the edge. Why are we moving more compute to the edge? I'd love to hear your take first, and then I'll kind of give my opinion on why we're moving more logic to the edge.
Yeah, so the space that I come from, containers or even serverless, in the cloud, we tend to think about regions and zones. So ideally, you get as close to the customer as you can, but typically you're still running out of a centralized data center. And for the most part, this works just fine for a lot of people. But when you think about use cases like gaming, for example, you really want that client, wherever the customer is, to be connecting super quick to the edge. Also in my world, the explosion of CDNs. As you think about the Netflix use case, or you're serving images, you want those to be as close as the customer as well, so they can render fast, load, and you're not pulling data across continents. So I think that's been our first taste. So for many people, why edge? And it's like, why edge for specific things? Some people are still comfortable with centralizing some of the logic, maybe your order management system or your company or customer profiles. I think a lot of that is still largely centralized, even though we've moved it closer to people at the continent level. But I think there's always been a case, at least in the last 15, 20 years, of moving static assets like videos and images to a CDN, which tends to have way more locations than our standard regions.
I love the 2 points you made about, one, just trying to get content closer to users, but then also effectively using the right tool for the job. It's not that we're moving every single workload to the edge. It's another tool in our tool belt that's enabling us to build better applications for the web. I think when I look at why edge and just the landscape of web development in 2021, it seems like what appeared to be static for a lot of sites is actually kind of deceptively dynamic, because the requirements for personalization and experimentation kind of put us in this tough spot as developers, where if you wanted to have dynamic, you might have to, especially with a global audience, you might end up with a slow application. And if you try to solve that, like solve the speed problem by making it static, well, now you lost the personalization or the dynamicism. So it's been difficult to get both. So where I view edge is kind of trying to solve both of those problems together, dynamic at the speed of static. And I think historically, your context about CDNs, when we went to the edge with edge networks or CDNs, we lost a lot of the abstractions that people coming from the server world, like express middleware, right? We lost some of the control and flexibility there. So we're trying to bring that back with edge functions, and we're doing it through an abstraction called middleware. So it essentially allows you to run code before a request is processed. And then based on that request, you can modify the response with rewrites or redirects or headers and all that stuff, trying to enable code over configuration and get closer access to that infra at the edge, like running as much compute at the edge as we can for specific use cases, like you mentioned.
Yeah, so the good news is I got to put my hands on it. And so, the limited front end experience that I have comes back from like the PHP days, right? You would render as much as you could on the server side, and then you would send over, a bunch of other things that then may do a little bit, the jQuery days where you can kind of context switch based on limited information you had from the browser or maybe the user session. And so I looked at how some of these frameworks evolved over time. And I've always had this question, is like, where do you put things like secrets or database connections? And it seemed like the industry had evolved to the point where you could have maybe individual components like the calendar widget or the stock ticker widget, but they always seem to talk all the way back to the back end, right? So you got as close to the customer on the front end, but then there would be parts of it that will still have to travel over long latency stretches to work. And I think what we tried to do then is solve the problem of async, right? They just kind of load at their own pace. Maybe you're getting some of that data from a cache if it's not really personalized for a user. And then I touched the kind of new stuff that you all are talking about with some of these edge functions. And so the first experience that I had there was like, this feels more like Ruby on Rails. So Ruby on Rails is this really powerful kind of convention over configuration framework where you could just, design your app in a certain way, lay out certain, folders and structures. And then when you built the app, it did all the right things in terms of rendering kind of this backend applications with the best practices. I think you all are trying to do that for front end and addressing some of these going all the way back to the central server by having parts of the application run in this new serverless edge computing platform where I kind of get both the best of both worlds without necessarily thinking about how I deploy each and wire them back up.
Yeah, I think I 100% agree with that. And I feel like it ties into this evolution of the traditional way we were building web applications and how we're trying to help bring developers on that journey to the future and bring them along with us as we enable and give these primitives to try to make it easier. So I would love to dive into this topic a little bit deeper because I really appreciate your experience and your context on some of this. I'll try to give my perspective as a front-end engineer and as somebody who doesn't have as much experience in the infra side, and I'm curious to see how it kind of compares against yours, because I know that you've spent time as a system administrator, you've been an advocate for Kubernetes, and because of that, you've moved along from manually configuring VMs, moving up the stack to Kubernetes. And I feel like when I've listened to you talk before about this, you try to root yourself in like the first principles of web development, right? Like it's important to understand we're fundamentally just writing software and it's going to run on a system somewhere. And the closer that system is to your users, ideally the better. And we touched on this a little bit before we started, but ideally you could have that system be the browser, right? That's as close as you could possibly get to the users, but it's not really practical to run all of your compute there. So in the front end world, from my perspective, React has essentially become like Linux. It's this open standard for building the web. And then you have Next.js, which is the most popular distro of using React. So an analogy I like for the backend folks is like when you're using Kubernetes, you might be using tools like Helm charts as an abstraction to define your infrastructure. So this is, for those not familiar, it's like infrastructure as code. And then you can develop and maintain your infra the same way that you would your code. But at the end of the day, those tools are just compiling down to like YAML, right? They're just making it easier. They're an abstraction layer on top. Edge functions, in my opinion, are very similar. They allow front-end developers, back-end developers to write JavaScript that ultimately just compiles down to some serverless compute that's running at the edge. I like to think of it as like infrastructure defined from code. So a little different than that traditional model. What do you think?
Yeah, so I think when I think about context is, if you think about the base principles of it, there's a database, your system of record. It has all the products and the prices of those products. And then your goal is to try to render a shopping experience to people that are using a web browser. So in that world, my server is going to say, hey, you hit this URL. I'm going to present to you a page with my entire catalog in it, and then you can browse around in that experience. I think the challenge is I need to render your shopping cart uniquely to you. So I'm going to have to go back to the server and tell the database what you've bought to make sure that my database and what you see in your browser are in sync. And I think that's been the traditional model that we went about doing this. Yeah, and so you're right. In the Kubernetes world, that backend application, I did a lot of work to give it a configuration file with the database username and password. So only that backend application could connect to the database. On the front end, there's a lot of work that goes into identifying who you are and then having your browser session pass back those credentials to my backend so that I know that I can look up data in my database and take actions on your behalf. I think now what we're talking about is moving some of this logic even closer to the edge. And now you get into some real tricky situations where I can't give you my database password in the browser. This would be a nightmare, and you could actually do anything on behalf of any user. So we know we can't go that far with things like database connections, right? So we got to move that one layer outside of the browser. Now, typically, That would be something like even a serverless platform like Lambda or Google Cloud Functions. That's one layer. And then at that point, you're just giving connection details to some API on behalf of that user. That all makes sense to me. But I think now what we're saying is, do we really need to go all the way back to even a serverless function or a container running in Kubernetes? Could things like how we process headers, like if you're coming from Australia and I might want to show you a different set of content, well, I can make that decision now in the edge, aka where the CDN traditionally sits. I think that's where it's going to get super interesting. And now I think as people coming from the front end or from the back end, we now have a decision to make. Where do we put this kind of logic and where does it make more sense?
So I'd love to pause here and to actually look at some code that kind of explains what you're talking about. How can we push authentication or logic closer to users, a layer back from the browser, and make that have lower latency in their requests? So let me share my screen and I'll pull up some code. So I know that you've had a chance to check out edge functions ahead of time. And one of the ones that I think is really interesting is using JWT authentication. So in this example, I have this edge function that's deployed and it's checking this JWT or JOT token. And essentially there's two different API routes. We have one that is just a normal API route, and then we have another one that's actually using an edge function. So to try to demonstrate this, what I've done is have two different APIs shown below, one that's using edge and one that's using just going to origin. Now, this isn't perfectly realistic because it's not actually doing the full authentication with some provider, but I think it helps to at least illustrate some of this. So ideally, you're going to see the edge responses be a little bit faster. And I'd love to take a look at some of this code and kind of talk through what that looks like. So on the left, inside of this example, we have our pages folder. And the convention that we're using to define how you invoke this logic is called middleware. So inside of our API folder, we have a new file _middleware. And inside of here, we're taking a look at the URL. If it has the parameter of edge, then we can essentially directly respond and handle that authentication without having to do that extra check towards the API route. So then this logic actually runs before the API route logic. Now, this logic, it effectively does a very similar thing. It looks at a cookie, it verifies a token, and then it returns some payload based on that. But the interesting part is when this actually gets deployed on a platform like Vercel, this could get deployed as a function somewhere, and this can get deployed as an edge function. So the difference kind of between a serverless and an edge function here is the edge function is another layer closer to your users.
Yeah, and so this makes a lot of sense to me because when I look at this traditionally, when we try to do this type of logic, we used to use things like Nginx or Apache. We would go find some module and you would go to the centralized system. And as a developer, you would have to know how to edit a Apache config, maybe even restart that server and wire everything up to do this kind of logic, right? So I want to add authentication to this app. Now I got to go hunt for one of these systems that I should go do it at. I think now what we're getting, and if I understand this correctly, as a developer, I can stay within my same application logic and then just add this middleware, not deploy to a backend server, not touch Apache, but just stay in the same flow that I'm already in and just say, look, I have this logic, will never go to the browser. I think that's kind of the key point here. It's going to instead get deployed somewhere where Vercel's platform is going to wire it up automatically, intercept the traffic, and then do all the logic that's in here. And then I just hit save, redeploy my app. And now I have this thing that just sits in the middle without thinking about touching 5 or 6 different places and restarting things. I think that is probably the thing that might blow people's minds in terms of you have this self-deploying thing that knows automatically from convention that it needs to get deployed one layer below the browser and just be available everywhere.
Yeah, and I think building off of this too, it's enabling a new set of developers to take advantage of some of these tools that maybe they had deferred to another part of the team or they thought was outside of the scope of what they could do. And another interesting example of this I can show is let's say you have some API and you want to do some kind of rate limiting with it. Let me pull this up here.
And as you're showing this, the thing that comes to mind, though, maybe, I don't know how we answer this question, but typically one benefit of the centralized world is that I can define these things like rate limits, in one place, and then all applications can just point to my centralized kind of middle, proxy, Nginx or Apache, and I can just handle everything there. What challenges does this present if every developer and every application is kind of embedding this logic and I need to go make a global update to all the components? What's the trade-off being made here?
Yeah, that's really important to talk about because I think we've seen developers want to move closer to the edge. And because their edge compute and logic was decoupled from where they were actually deploying their application, they were two completely separate workflows and pipelines. And because of that, you could often get into instances where your systems got out of sync, essentially. And even on a fundamental level of caching, now you have two caches in the mix. So the closer that we can marry the infrastructure to the code that we're trying to write and define helps developers fall into that success pattern where they can use these primitives and not, shoot themselves in the foot essentially by putting in logic that is going to ultimately end up in a bad experience.
Is there a way to share some of this logic? Let's say developer A writes the perfect, geo redirect function. And in my mind, coming from my world, I would like to write that once, put it somewhere and give it an endpoint, and then have people just call that as like another API component. Is there an opportunity to do things like reuse logic versus it seems like maybe embedding it in every app that I'm working on?
Yeah, I think that's a fundamental part of what we want to achieve with edge functions and through the abstraction of middleware is empowering developers to bring back some of that flexibility that folks are used to with things like express middleware. So whether I'm doing an authentication check, whether I have this library here for IP blocking in this example, all these things that are going to start to be pretty common use cases for middleware, I want to abstract those out into a reusable package and use them across different projects or make them open source. And the nature of, bringing middleware to open source in Next.js and other front-end frameworks is that they'll be able to npm install these packages and integrate them into their existing systems. So the constraint here, and part of the reason why edge functions are fast, is the underlying runtime that we're making. So we're making a trade-off by not exposing the entirety of Node.js APIs and instead constraining the runtime to use standard web APIs like Fetch or Crypto and being built on top of the JavaScript V8 engine. Because of that, we're able to eliminate some of the remaining trade-offs that you had with serverless. So the cold boot problem, connection pooling, and more easily deploy these functions globally. So if I want to abstract this logic for blocking IPs, I can put it in an ES module that's not using any specific node APIs and then easily install that and share it across my team.
All right, now this starts to make a lot more sense because now that I'm looking at it, this is how we do and think about network configurations, right? There is like a module that does things like IP blocking, and then it's on the developer or the operations team to configure what IPs they would like to have blocked and for what reason. And so it seems like if I were to centralize this into a high-level library, then I could easily just say, hey, what you're really doing with this middleware is deciding how it's being used, like configuration, if you will. And then that module and that code can be reused. So my guess would be, if I wanted to centralize that, I would just treat it like any other software package, version it. And then if we want to roll it out everywhere, someone would just do a redeployment and you would pick up all those changes and it will be pushed out across the entire edge.
100%. Yeah. And to take that even further too, like there's so much of this logic that we could be abstracting out to share. Like to further hammer home that point about IP blocking over here, I can essentially enable these developers to put in any IP address they want and, add it to a global configuration of some some list of blocked IPs, whether that's manual or automatic. So maybe you want to manually do this configuration, or maybe in this example on the left, you want to set up a middleware to have an API that automatically rate limits with exceptions around, bearer tokens or some kind of auth token. And if they have that token, then we want to up those rate limits quite a bit because we know that they're a trusted party of using this. And that essentially comes down to a few lines of code, assuming that this right now, while it's in this repo, you could really easily abstract this out into a library, and then it's just a rate limit. And that's the only code that you need.
So one question I have from this, because this is genius. So this looks like what we used to do with things like Lua modules and Nginx. But again, we would have to do it for every route, and it could get super messy, and also was so disconnected from the actual application. The one question that kind of stands out for me here is, where do you put the config? For example, if I do have like 35 IPs that I want to store to check against, I don't see a config file here. Would I actually have to establish some other data source, like a database, or I think you're using Upstash, which is like, I believe, a Redis compatible API that's hosted somewhere else?
Yeah, the great thing about Upstash here is we're using it as a REST API for Redis, and it's globally distributed, deployed across the world. But you bring up a really good point, which is we've given you this abstraction, we've given you the tool, but what about the data layer? How are we going to solve that piece? So right now, from a Vercel perspective, the edge functions on our platform currently don't have an integrated key value storage solution. But that's something that we're actively looking to support to eliminate the need for a developer to go outside of the platform to find a place to store that configuration. Now, over time, we might see that evolve even further, but I think key value is really the first concept for us to nail that is very compatible with use cases for edge functions.
All right, now this makes a lot of sense, because now I think you kind of solved the configuration problem. As I make changes and decisions, either in real time or dynamic, then I now have a place to kind of store the actual output of some of those decisions. And also some of the things like caching layers. If I've already made a decision, the last thing I want to do is recalculate the decision in a small window of time. I guess for me, it's like, what doesn't go into this layer, right? To really understand something, I always think it's important to know when not to use it. Should people be thinking about taking their entire product catalog and stuffing that into a CDN or Edge or something like Upstash?
Yeah, that's a great question. It kind of comes down to where we see the future of web architecture headed. So specifically, if we look at databases, I think we're seeing this new breed of databases that are edge first. So we talked about key value stores, but it could be a SQL-like schema or evolving databases that we already know, like Postgres or MySQL, to run global first. And I think when you ask what doesn't work, we're seeing that a lot of these applications are getting modeled after eventual consistency. So with e-commerce, they might be favoring speed over global consistency. And in my opinion, we're kind of going all in on that model, allowing people to essentially granularly cache things at the edge. Now, what those things are, it might be compute, or it might be actual React components. And we can dive into this a little bit later, but it's still then allowing you to pick back up on the client side and have the full power of JavaScript. So I think that when you look across different industries, e-commerce, but even in finance or other sectors, databases are kind of going global, and combining that with the edge is just trying to make it fast everywhere. Does that mean that we need to move everything to the edge? I would say no, especially if you're trying to do something that has a hard requirement for global consistency. In my opinion, the eventual consistency model just maps better for this type of logic.
But I also think we're thinking about better access to those type of systems, whether it's centralized or distributed across an edge. That comes, I guess, as an implementation detail. If I have the ability to reach these type of systems from this new kind of function framework, then does it matter where it lives, right? I could sign up for a hosted service, and all I'm concerned with is latency to my data. And if they can achieve that by putting my data and replicating it very close, then so be it. So I think maybe that's where we're headed, is just the distributed landscape, similar protocols, and we're cutting down things like latency and some of those challenges by bringing things closer to the compute.
Yeah, the way I like to look at it is I think that hopefully it's a natural transition up the stack for backend developers who are trying to learn more about serverless or edge, because in making the constraint about the limited runtime and not being able to use node APIs inside of an edge function, I feel like in getting rid of some of those trade-offs that they might have previously correlated with serverless and trying to make it fast by default, I think will help them adopt and understand the use cases for a lot of the applications of edge functions or middleware. And then to your point about like where this will grow. So right now with the Vercel platform enabling edge functions, we're already seeing, I think, a rise of this type of edge compute across the industry. And my expectation is just to see this continually rising, not only for compute at the edge, which has been around for a few years now and rising in popularity, but also running your actual application rendering at the edge. So the way I like to think about this is a lot of that sounds kind of like 2000s web, like you just server render and you get your page. And there was this transition from let's do everything on the server to let's do everything on the client. And some people fought back about that. Not everyone thought that was the best approach. And now I think we're kind of converging and coming to this happy medium where we say, actually those server people were right, and those client-side developers, well, they were also right about some things too. We want to take the benefits of the 2000s web of fast single page or fast server rendered applications and marry that with some of the inventions that single page apps or client-side apps gave us with fast navigations through prefetching of routes. You click on a link and it feels instant. It feels like an app. So what I see the edge doing for the future of cloud computing and the future of the web, especially with innovations like React Server Components, is bringing back the server first model and getting quick responses directly from the edge while still remembering the innovations that we made on the client side for interactivity to then hydrate or add more logic after your page loads. And I think
one thing I can think of here is that the networks have gotten so fast, whether we've just made them bigger and closer to where things are happening, that we're almost now at the point where we can treat, there was this saying, we can treat the data center like a computer. But now with these networks so advanced, you can almost treat the internet like a computer itself. And so now the operating system, and now, through this conversation, Vercel just feels more like this operating system for this kind of distributed computer that says, hey, just like on a single server, that some things will get loaded into memory and some things will be paged to disk. Some things run in kernel space, some things run in user space. And sometimes we create these boundaries for security reasons. Sometimes things just don't make sense to run in one place over the other. And I think computing, we've always had this trade-off between security and speed. And you put things in the right place. But I think now what you're doing is trying to blur those lines to say, what if we just treat the whole internet as a computer and we'll just locate things where they need to be in order to satisfy those two concerns. I did learn a lot just from having this conversation. So I think other people that are watching, if they watch the whole thing, asking these kind of questions back and forth, they're like, why are we here now? What does it bring to the table? And even having that code walkthrough, I think was really helpful for people to mentally map what things are happening. But yeah, I think Vercel as an operating system for the internet, I think it just makes it easier to grasp what's happening. You got to just let go. You got to let this thing figure out where things need to be deployed, wire them back up, and own how it works. And that's what kernels do on operating systems.
Yeah, I think developers thought it would be easier to decouple their application from the infrastructure. And I think where we're moving, it's like, but there's actually a lot of trade-offs with that. There's a trade-off with the flexibility of moving your application, but there's also a lot of value in the closer you can marry those two together. And the great thing about Next.js, in my opinion, is that when you deploy Next.js to Vercel, you're making the trade-off to marry those two together, but its core is still open source. So if you decide, I'm done with Vercel, I don't want to pay them any more money, and you say, I'm going to go host Next.js on GCP, you totally can. Because all of these primitives that we're introducing, like middleware, it would just run on a single origin server. So I really like that because it's still bringing value to the entire ecosystem and eventually to other frameworks too. the way we've designed this abstraction on Vercel is that it will work automatically with Next or Svelte or any of these other languages or frameworks just by conforming to our API for how you implement this.
Oh, that's dope. That's going to be good to call out in the docs and when you give people the experience, because some people, I think that is kind of the question we hear when we think about these new platforms. They feel like black boxes, and it reminds people of kind of like lock-in, but it sounds like that's going to be addressed up front in this design.
Yeah, and the way I like to think about it is we're moving to this world where if we truly do build the SDK for the web, people will still have their syntactic sugar and preference of choice, and there's no way to get around that, and that's okay. We should be empowering those developers to make innovations in their own spaces, but we still want to give the same shared Legos and building blocks for creating a great web experience. So when I look at the Vercel platform, we're investing heavily in what we're calling the file system API, which is conform to this file system output, dump it on our operating system, and it will just run globally and use all the features that are possible. And it's so easy then for framework developers. I could go out and build my own framework today, and it could have web vitals analytics, image optimizations, edge functions, serverless functions, CDN caching, just by conforming to some output.
No, it makes sense. I think now that the web may have finally found its operating system.
I love that tagline. I think we're going to steal that. And on our homepage, it's going to say Vercel, the operating system for the web, co-signed by Kelsey Hightower.
There you go.
Well, thank you so much for taking the time to chat today. I really appreciate it. And for those watching, I hope you enjoy the rest of Next.js Conf 2. There'll be lots more content around edge functions.
Thanks for having me.
Thank you.
Hi, I'm Tim, CTO and founder at Checkly. Checkly is used by the best dev teams to ensure the reliability and performance of their web apps and APIs. Let me show you how you can monitor your next app with Checkly. First, you use our powerful JavaScript-based browser checks to make sure your web apps work reliably and fast. We automatically give you web vitals, console logs, network data, and a lot more. Then you add some API checks to make sure your backend APIs are snappy and respond with the correct payload. Of course, if anything fails, we will alert you on Slack, email, SMS, and a whole bunch of other channels. Lastly, you hook this up to your Vercel account with our new deep integration, so you never ship any broken web apps again. Sign up for a free developer plan over at checklyhq.com.
Your app just crashed. The phone running it has exploded. It was struck by a hammer manufactured in 2005 by Harry's Hammers. The hammer's head is composed of 75% nickel, 20% steel, and 5% iron. The phone flew into the air at an 86-degree angle and came crashing down at 11 miles per hour.
Oh, hello there. My name is Cap and I do developer relations at Sanity.io. And this is Bella. She does developer relations for Scooby Snacks. We live in Las Vegas, Nevada. And a fun fact about both of us actually is we both really love anime. So in this talk, we're going to cover conformance in Next.js. Come with me. All right, so like I said, this talk is on conformance, and conformance is new to Next.js, and it's a beautiful addition, if I do say so myself. Oh, and this is Hilo. Hilo loves treats, as you can see. So a quick history on conformance. Google had a small team of very experienced developers who did all the extensive code reviews, of course, and would flag anything that impacted app quality. So they thought, why not take the common things that were being found and make a system out of it? Thus, the conformance system was born. So this automated and enforceable system ensured a consistently high bar for app quality. That's pretty nice. So Google's web platform team experienced heavily with Next.js and began open sourcing their system. So Next.js knew it was time to get this automated system in Next.js. And that's what we are going to be talking about today. Here with me to explain this next part, the most important part, is what is conformance, is Polly. Now, I don't want to call conformance a new feature of Next.js because you can't really describe it as a feature. It's more a system that solves problems or points out problems in code. So there are rules that conformance follows to support the optimal UX experience. It catches things that might only be caught from an extensive code review or months down the road when a user complains about an image not loading. So some error or warning messages you could see in your Next.js app could be using an A tag to navigate to a page rather than link from next link, or using a link tag for an external style sheet rather than importing the styling files. Now, there's a lot of rules you can find that conformance would help catch in your code. So what I realized is that having conformance is like having a senior developer with me pair programming at all times. Super nice. And that takes me to the why. Why does this even matter to me? Can you imagine being able to have optimal code to create an optimal experience for your users without having to run it through another developer for a code review? Now, okay, conformance doesn't take away that need for the code review, but it surely wipes out a lot of the quick fixes to optimize your project. It takes the developer experience of creating a website or project and gives tips on how to improve your code. That ripple effects onto the users. Now the user experience is optimized and they get security, accessibility, and performance at a better rate. So added to Next.js 11, it was released on June 15th, 2021. That means you may not be affected by this yet. So to do a quick check, look into your package.json of your Next.js project to see what version of Next.js you are running. If you find out that you're outdated, that's okay. That's why we have the internet, so you can learn how to upgrade that awesome project of yours. And I'm going to show you exactly how that's done. But first, let me tell you a quick story. So I got into tech about 3 years ago and was first exposed to React then. I was a React fan from the beginning, through and through. And then Next.js came along. It's kind of a sweet code love story, but I'm grateful it didn't have to become a love triangle between my first love, React, and my new love, Next.js, because Next.js is React. So as Next.js gets better and more optimized, I realize how good it really is for us developers. And conformance is one of those, like, you shouldn't have moments. I get a better developer experience by making sure my code is optimized for my users. It's too easy. So one of my projects was old Next.js. It felt new to me though. But then I upgraded and I ran that beautiful lint command, and let me tell you, there's a lot of errors. But I won't tell you, let me show you all that. All right, so to get our Next.js application upgraded, we are going to run the command npm I next latest, react DOM latest. And this is going to upgrade us to Next.js 11. So now we are upgraded. We are next going to run the command npx next lint. How do we like to configure? We'll do strict because that is the recommended way. And all of this is going to be added in. Now we will need to run that command again in order to get all of our warnings and our errors to optimize our code. So now that that's done, let's run it again. Running that next lint command. And there are all of the warnings and errors that come from my application, my next app. So let's go through a couple of these. So at the very top, there we go. Now we're at the top. So one of them, do not use image tag, use image from next image. Great one. Custom fonts not added at the document level. This is discouraged, and it tells you where to go to find out more information, and it tells you which file this is in. Another one, external synchronous scripts are forbidden, and again, exactly where to find more information about that. This assign arrow functions to a variable before exporting. We're going to actually look at this one more in depth. We'll keep scrolling. This is a good error, the apostrophe. This can be escaped with the HTML character, and there's like a list of ones that you can choose from. Here's a good one, React hook use effect has a missing dependency. Great warning and great to know. Let's keep scrolling. And we have a lot of these. Image elements must have an alt prop. Don't forget those alt props, and we'll show an example of that. And my giant list of missing keys. We'll definitely want to fix those. That's probably all 47. Just kidding, I don't know. So yeah, that is my list of errors and warnings. So the first one, let's look at assign arrow functions to a variable. So it shows us where to find it, that it's a warning, so it's going to be yellow, and what the error is. So we're going to go to the file, and we see underlined in yellow the error and what the warning was. So we're going to fix that by naming it. And best practices is naming our functions. By naming our functions, we are able to debug better, and our code is optimized and organized. So we've named it with the function headline. That one's done. Next one, the apostrophe can be escaped with the HTML character, and it gives you a couple options to choose from. So we go into our code. It is an error, so it's underlined red. It shows the error, and then quick fix, view problem, that kind of stuff. We've added in the HTML character, and now that error is gone. So that's really awesome because we want to have that HTML character in there instead of the apostrophe. Next one is the giant list of missing keys. So we're going to want to fix all of those because it's good to have the key. And if you look to the right, you see all the red for just this file where there are missing keys. I'm not going to show you me fixing each one of these, but as we add a key to each one of these, that red line will go away. Next, we have do not use image tag, use image from next image. And we also have image elements must have an alt prop. So let's go fix that warning for both of those for this one. So we have both of the warnings pop up when we hover, and we have that yellow squiggly line behind it. So we know that we are in the file that has the warning associated with it. So to fix it, we import next image. We use that image, and we also added in the alt prop. So by doing that, we have optimized our image handling in Next, and for accessibility, we have the alt tag. So we're good to go. So there you have it. Next.js comes with a handful of awesome new features or systems, Conformance being just one of them. So go ahead, hit that upgrade command today, and let me know about your developer experience with Next.js 11. Thank you for coming to my talk. My animals also thank you. You can find me on Twitter at Kapehe_OK, where I tweet all things tech, working out, and miscellaneous stuff. You never know, I never know. Mahalo for hanging out, and we'll see you around.
Hi, I'm Taylor Barnett, and I'm here in Austin, Texas. And I want to talk to you about this idea of practicing databases as code with PlanetScale and Prisma. So first, what is PlanetScale? PlanetScale is a MySQL-compatible serverless database platform that aims to get you using relational databases as fast as possible. You can start PlanetScale in seconds, and it scales with you indefinitely without having to worry about things like connection pooling or connection management. PlanetScale also allows you to branch your database schema just like your code. You can experiment in an isolated database branch and then merge back into your production branch with non-blocking schema changes. It's all about the good parts of a relational database without the harder database operational challenges. Now, when using PlanetScale, you'll need a way to access your database from your code, which is where Prisma comes in. Prisma is a next generation ORM for JavaScript and TypeScript. So Prisma is a different kind of ORM. So traditionally with ORMs, they provide an object-oriented way of mapping when working with relational databases by mapping tables to their model classes in your programming language. And while Prisma has you define your models instead in a declarative Prisma schema, where you also define things like database connections and you generate the Prisma client. We'll also be using the Prisma client in the demo. I'll do a little bit after this, but the Prisma client is a query builder that is both type safe and allows you to write less SQL. When working with data models, you'll also need to be able to handle migrations, for example, which is where Prisma Migrate comes in. We'll also use it in our example. Prisma Migrate automatically generates schema based on the changes in your schema file, and it can detect things like drift and help you resolve those problems. And lastly, Prisma Studio, the third part of it, is a lightweight interface for your data in your database, which we'll also briefly use today. And so one of the reasons why I think Prisma fits so nicely with Next.js is because of all the different ways we can access our data within a Next.js application. You can do it at build time with Git static props. You can do it at request time with Git server-side props. Or you can even build it into an API route, which we will do today. And lastly, you can even separate the backend out and use it as a standalone server. The last thing I want to cover before we jump into some code is why does this stack fit so nicely with this idea of databases as code? So first, when deploying our Next.js applications today, you're likely using a tool that is very Git-centric, like Vercel. Vercel pulls the repository to create deploy previews, for example. Core of this concept of Git is branching. But often that has not been extended to other areas of our infrastructure, like databases, for example, which is possible with PlanetScale. Being able to branch our databases is crucial for this idea of databases as code. We need to be able to have these isolated environments to experiment in alongside our code. And then when we're done, we create a deploy request similar to a pull request for our code. Now, having these models as declarative schema also makes them not only more portable, but also makes things like version control and automation with our databases more possible. If you're familiar with configuration as code too, then you're familiar with this idea of having this like configuration file, in our case, a schema file that, we can declare certain things so that we know this is like our single source of truth. So what are we going to build today? I'm going to start with a brand new Create Next app, and then we're going to add both Prisma and then PlanetScale, and then we'll make an API route using both of them. So let's get started. I'm going to switch over to my code editor, and then we are going to create our first database. So the first thing we're going to do, the obvious, create a database. We're going to give it the name star app, and we're going to select create database. One of the awesome things about PlanetScale is that it can track your migrations table. So when you do Prisma migrate, it will track that on the main branch. We're going to save that. And then we're going to go ahead and create our two branches. So the first branch is going to be called initial setup. And then we're also going to create another branch called shadow. The shadow branch, again, is for when we run Prism migrate. We'll talk a little bit about that in a minute. So I want to start with a brand new Next.js project. So I'm going to do npx create next app at latest. I prefer using npm, so I'm going to give it that flag. And then I want to call this star app, keep things simple, that we also named our database after it. And while that is building, I'm going to talk about what our next step is. The next step is that we're going to install the Prisma client. We talked about Prisma earlier, and that the client is one of three main parts of Prisma. So once this is done, I'll cd into the project, and I'll run npm install at Prisma /client. Now, this doesn't totally get us set up with Prisma, but we can see that, our package.json has been updated. We're going to do npx prism init, and this is going to create a few different files for us. We're going to go into that schema.prisma file and start editing the file. So this is very kind of like config-based feel to it. We're going to change that to MySQL because PlanetScale is MySQL compatible. And then we're also going to add the shadow URL. We're going to add an environment variable for that. Just call it shadow database URL. And then also we have a special thing that we need to add when we use PlanetScale with Prisma, this referential integrity variable. We're going to set that to Prisma. And also, so this is a preview feature. You need to also make sure that your client also gets generated with it. So since we have these environment variables, let's go ahead and update them. So we have a .env file that was created for us by Prisma. And I'm going to pull over a string that we're going to use to connect locally to the database in a few minutes. Then we also need a shadow database URL that we will use when we run Prism migrate. And then we're going to use it on a different port. It will be on port 3310. And after this, let's go ahead and create our star model that we're going to use for our API. So in the schema.prism file, we're going to do model star. We're just going to put a few things in it just to get started. The basics, an ID, which will be an int that will auto increment. Then a created at, date time. That'll be when we insert it into the database. And then as well as a updated at. Clean this up a bit. Now, I don't want to make this model too complicated just for this quick demo, but we'll do a name for our star, which will be a string, be a varchar, and we'll limit that to 255. And then also what constellation it is in. Also a string, the same varchar. And so there you have it. After this part right here, we have our model, we have our Prism client, and we have our database connection all set up and looks nice and neat. Now I want to connect to the database locally. I'm going to be using the PScale CLI, PlanetScale CLI. I've already installed it, by the way, so you might need to install that if you haven't already. We're going to open a few different terminals for that. So this is going to use those environment variables that we set up. It's when we run the Prism migrate, but first we need the actual connection. And so PScale's handling that connection to PlanetScale for you, so you don't have to mess with the connection string when you're developing locally. And then I'm also going to do one for the shadow database, which again is used when you do Prism migrate. And then that is to the corresponding port that we set up for that, which was 3310. So now we have those connected and we're ready to do our first Prism migrate. So we're going to do npx prism migrate dev, and we'll just give it a name in it. takes usually a few seconds to run, especially on the first time when it's creating everything. But after it runs, I want us to take a quick look at the migrations folder. And so you can see in this migrations folder what it actually created in SQL. And then you can also see this in the branch itself that we're working in, the initial setup branch in PlanetScale too. You can see that schema is on that branch, which is awesome because this, lets us test out potential different schemas before we merge them into our main production branch. So the next thing I want to do, we didn't have a lib folder. I'm going to go ahead and create one, and then I'm going to create a Prisma.js file in here. Now, it's important to note that PlanetScale can handle thousands and thousands of connections. But, since we're dealing with the serverless application, we still want to make sure that not every single time we're creating a new Prism client. And so part of why we're going to create this Prism.js is so that we can reuse the client. And I just pasted the code over to save some time, but pretty straightforward. It's just a Prism client using the library. So the next thing I want to do is go to pages, and then in API, you can see there's that hello.js that was there when you do the create next app. We're going to create a new stars.js. We're going to do a really basic route. I'm going to go ahead and copy and paste that into there. You can see we're using that Prism client that we just created. It's only going to respond to a get method. It's only allowed, and then it's going to find all of the star records and return that in JSON with a 200. Anything else will give us a 500, some kind of error fetching those. So now that we have created that, the last thing to do is actually give some data to our database. So I'm going to use the Prisma Studio, which you can do npx Prisma Studio, and it is kind of looks like a spreadsheet or something. I'm going to say Polaris, also known as the North Star, although there are multiple North Stars, which is in the Ursa Minor constellation. I'm going to save that. And then we're ready to start seeing some results. I'm going to close out of Prisma Studio, and I'm going to run npm run dev. Now, when I load this up, you're familiar with the standard Next app index page. We're going to go to the API /stars. And as you can see, here's our data that's being pulled from PlanetScale. Just to prove that this is actually in PlanetScale, we will even close this out. And then I will show you from the PlanetScale console within the PlanetScale web app that you can also see the data that is in your star table. Now, at this point, we feel comfortable. It does what we expect it to do. It returns us results. And so I want to create a deploy request to our main production branch to merge the schema change. We're feeling comfortable. We did our experiment. We've tested out in the branch, and there were no conflicts, so it's able to be deployed. And now when we look at our main production branch, we can view the schema that is on that branch. And here's the same schema that we had in our initial setup that was not there before. Now at this point, we're ready to deploy our application to Vercel. I'm not going to go through step by step because it's much like how you deploy other Next.js applications to Vercel. But I will include some details in the project's repository that you can see here on the screen. Hopefully, this gives you a good idea of the few steps you need to do to implement PlanetScale and Prisma into your Next.js application, and also this idea of how to use branching as part of databases as code. Thank you so much for watching, and let me know if you have any feedback on PlanetScale, on this workflow, like how does it work for you? How is it not working for you? What can we do to make it better? I'd love to hear, and have a great rest of your day. Thanks. Bye.
At Prisma, we redefine the developer experience of working with databases with a next-gen ORM. You write your data model in a human-readable schema, allowing anyone to quickly understand how your database is designed. You then get an auto-generated, type-safe query builder that you can use to read and write data to your database. And when your schema needs to evolve, you run a single command that auto-generates migrations for you. However, regardless of whether you use Prisma as your ORM, working with traditional server-based databases in a serverless environment, you run into an issue. Each serverless function opens a connection to the database, so during traffic spikes, you'll quickly exhaust the database's connection limit. This negatively impacts performance and leads to failed requests. That's why we've built the Prisma Data Proxy. It's a service that sits between your server and database and handles database connection management for you. It's currently in early access, and we would love for you to try it out. To learn more, go to pris.ly/dataproxy.
My name is Fernando Rojo, and I'm the co-founder and CTO at BeatGig. We're a marketplace for booking artists. You can think of it like Airbnb for live music. Today, I'm going to talk about using React Native with Next.js. My goal with this talk is to convince you that React Native is the best way to build a UI, even if you're only making a website. 1 year ago, we started building our product from scratch, and I decided to use React Native with Next.js to build the front end. In the time since, we have shipped over 100 screens. All of the code lives in a single monorepo. Our product works on web, iOS, and Android with full feature parity. This is all with one person building and designing the front end. As a result, we have grown from 0 to over 10 million in sales in under 1 year. Thanks to our cross-platform stack, we can iterate rapidly and ship features daily. Our number one priority is reducing the time from idea to deployment, and React Native is our greatest instrument in doing so. Combine it with Next.js, and you can deliver an amazing user experience on web. Now, React Native with Next.js is a relatively new stack, so I faced a few issues along the way. My plan with this talk is to break down each issue and show you how we solve them. We'll look at navigation, animations, responsive design systems, platform-specific features, monorepo support, and more. Let's jump in. The biggest difference in structure between a React Native app and a Next.js website is navigation. So let's see how it works. To the left, I have the BeatGig website, and on the right, the iPhone app. Let's compare what happens when I open some artist profiles. Okay, here we have it open on the website. I'll do the same on the app. Looks basically the exact same. I'll go back, and let's do one more. I'll open BOB on the website, and now on the app. So let's compare what happened. On the website, we have @BOB here in the URL. On the iPhone app, there's obviously no URL. And the only real difference is that on the iPhone app, I can swipe back here, and I got this stack transition in. So I'll go back, and I'll go back here on the website too. The key thing to take away here is the design is mostly shared, and the logic is fully shared between platforms. But we still match the user's expectations based on the platform they're using. Let's see how we do it. This part is really cool. We're going to use the same screens across Next.js and React Native. Our first step is to create a shared artist screen component. I'll expect every file in the screens folder to be shared cross-platform. Next, I'll create a Next.js page at pages/artist/slug, and I'll import that same artist screen component. All we have to do is default export it, and our artist screen is now working on Next.js. For the search screen, I'll create a shared search screen component, import it in pages/search, and default export it. If you use Next Router, this should look really familiar. We now have our React Native pages rendering on Next.js. The missing piece is, how do we use the same screens in the React Native iPhone and Android app? Here we're looking at app.tsx. React Native uses this file as a single entry point. Rather than use file system routing, we're going to create a stack from React Navigation. Here I've imported Create Native Stack Navigator, which does that for us. I'm also going to import the same screen components which we just used for our Next.js pages. Now I have an empty navigator, and the only missing piece is to add our screens. And there we have it. We now have our two screens uniquely identified by the name prop, search and artist. And the component prop tells us which component to render. This is what the final code looks like. The only difference is that I added navigation container, which is the provider for React Navigation. Let's recap where we just shared some code. First, I import the shared artist screen component in app.tsx for React Native. I then pass artist screen to React Navigation's stack via the component prop. To use the same screen in Next.js, all I have to do is import it in pages/artist/slug and default export it. And there we go. You now know how to share screens between a React Native app and a Next.js website. The question is, how do we move between screens? If you're on the search page and you want to open an artist page, how do you do it? Can you just use the next link? Or Next.js's router push? Or is there another way? Let's take a look. I made a library called Expo Next React Navigation, which lets you share all your navigation code between Next.js and React Native. This is what it looks like. It's very similar to Next. It has a link component and a use routing hook. You can create a custom link like this to open an artist, and if you need more customization, you can use the web prop if the route name from native doesn't match your path on web. Unlike Next Router, it uses params instead of query, which does the same thing. Reading in our params is also very similar to Next. This is what it looks like on Next, and with Expo Next React Navigation, instead of query, we just use params, and everything else is basically the same. In the future, I want to have an API like this, where it's fully shared between Next and React Native. But there are still some things in the way. And if you want to help, you can check out this issue I opened on the repository called the Future API. And I would love to hear your thoughts and get your contributions. Next, let's talk animations. Coming from a web background, I always loved using simple things like CSS transitions, and more advanced libraries like React Spring and Framer Motion. In the past year, there have been some incredible innovations for performant animations in React Native, with the introduction of Reanimated 2. That said, before I even started using React Native Web, something I felt I was missing in React Native when it came to performant animations was a simple API. In 2019, this feature request was opened on the Framer Motion repo for React Native support. It was one of those issues that got a ton of attention, a lot of upvotes, but was outside of the scope of what Framer Motion was focused on, which was just the web. This inspired me to write an RFC in October of 2020 for a simple cross-platform animation library for React Native and React Native Web. I wanted to borrow a lot of the cool features from Framer Motion, like mount animations and automatic transitions, and I ultimately decided to build my own library called Modi, and I launched it on Twitter about 8 months ago. In the time since, Modi has gotten almost 2,000 stars and has gained quite a bit in popularity. This is what it looks like to use Modi. You get a Modi view and a Modi text component. You can use the from prop for mount animations, and anything you pass to animate will automatically transition, which makes it really easy to animate based on React state. You can also get full control of your animations using the transition prop like Framer Motion. One of my favorite features of Modi is the mount and unmount animations. Under the hood, Modi uses Framer Motion's Animate Presence to bring this feature to React Native for the first time. In fact, Matt Perry from Framer Motion recommends Modi as the native compatible alternative. If you want to animate based on hovered or press states, with Modi, it's as simple as passing a function to your animate prop. You can interpolate between hovered and press states, and the results will automatically animate without triggering any re-renders. That means we get cross-platform animations that run at 60 frames per second. One of my favorite design patterns is animating a component when someone hovers or presses it. Notice what happens when I hover over the See More link. See that the background turns yellow. And when I hover over an artist, they scale up. Getting this kind of feature parity between a website and an iPhone app would previously be really challenging. But with React Native Web, and Modi, this parity comes out of the box. To the right, we have the BeatGig iPhone app. Let's see what happens when I press on the See More button. The background also turns yellow, just like the website. And when I press in on the artist as I scroll, they also scale up the exact same way. With Modi, you can also do more advanced interaction-based animations, such as animating the children of a pressable component. If you open the BeatGig website and hover over products in the header, you get this nice drop-down. Each item has a background transition and an icon that animates in or out. This is actually built with Framer Motion and React State because I hadn't launched Modi interactions yet. But once I shipped this on the website, I wanted to try to remake it with Modi. Here we have the exact same component from BeatGig's website built with Modi. What I find interesting is this is a web-only component, and yet implementing it with Modi, which is a React Native library, was a lot simpler than doing so with web libraries. I think this is a common side effect of building with React Native and React Native Web. Rather than focus on platform-based implementation, you think strictly about the UI. And as a result, you come up with APIs that are a lot simpler than what probably existed. The code for this dropdown is open source, and I'll link to it at the end of the talk. Next.js is a first-class citizen of Modi. Add Modi to your Next transpile modules, add a single polyfill, and you're good to go. Let's look at one final animation example, animating based on scroll position. On the right, we have the BeatGig iPhone app. To the left, the mobile website. Notice that the header fades in when I scroll down. The animation code here is shared 100% cross-platform, and there's actually no special library in play here. This is using the vanilla animated API from React Native. For simple things like scroll animations, this API is quite easy to use and can get you great performance. Next, let's talk theming and responsive design. Back in 2017, I was running an e-commerce sneaker brand called Patos. I wanted to make some custom edits to my Shopify website, so I started learning CSS and JavaScript, and it didn't take long to fall in love with both. Soon enough, I considered myself a web developer. I was using CSS all the time. So when I started styling in React Native, I had some mixed feelings. To start, let's compare what it looks like to style in CSS and React Native. Next, I'll discuss the pros and cons of React Native's styling system. And finally, I'll show you what we do. Here we have a component class name written in CSS, and at the bottom we have the equivalent in React Native. React Native has a built-in stylesheet API. Rather than use class name, we'll pass this to the component directly using the style prop. If I want to use multiple styles, I just pass an array. In this case, I'm forwarding props.style. The order of the styles is determined by their order in the array, which is a lot more predictable than CSS. I can also do conditional styles. In this case, I'm only applying props.style if props.is enabled is true. Finally, if you want to add dynamic styles, you can do that by putting them in line like this. For a deeper understanding of styling in React Native, I recommend checking out the docs. But hopefully that gives you a good overview of the differences with CSS. Next, let's look at the pros and cons. First, the pros. There are no global styles in React Native. At first, I viewed this as an annoying limitation, but it's actually crucial. If you want to know the styles applying to a component, you just look at the style prop. It's dead simple, and there's no risk of accidentally setting a global style that has side effects on other components. Similarly, there are no nested styles like there are in CSS. All styles are scoped to a single component, and the logic is handled on the JavaScript side, making each component incredibly predictable. React Native also doesn't have pseudo elements. If you want to track a component's focus state, you use the onFocus prop instead of the CSS selector. This is a lot safer, as it maintains your components as a function of their state, and you can come back to it months later and know exactly what's going on. Finally, in React Native, there are no issues with import order of styles. With CSS, you can cause many bugs simply by the position in which you import a file. On the other hand, in React Native, if you want to know the order of styles that are applying to a component, you just look at the style prop. There are no cascading styles, no nested styles, no global styles. Everything is scoped to a single component, which means your component-based design system is scalable. For a long time, I thought I loved CSS, and part of me still does. But once I started styling with React Native, it was pretty hard to go back. The level of predictability and simplicity lets you move so quickly and keeps you from getting bogged down by little CSS bugs and platform-based issues. One interesting thing is the Stylesheet API from React Native Web is actually a highly optimized CSS in JS solution. If you want to see how companies like Twitter use this on their website, I highly recommend this talk by the creator of React Native Web, Nicholas Gallagher. Okay, now the cons of styling in React Native. React Native doesn't have CSS grid. This isn't the biggest issue in the world, but it would just be nice to have it. Next, React Native doesn't have the concept of media queries, so responsive design can be a bit challenging. You have to actually use JavaScript to track screen dimensions in render. In fact, React Native Web actually recommends not using media queries. Instead, they take the position that you should render different component trees altogether based on screen size or view container size. So, what's the verdict? I've spent a few years building with both CSS and React Native, and ultimately, the low-level styling API provided by React Native and React Native Web is better than that of CSS. The level of predictability and scalability in a component-based design system is too hard to beat. Now, there are some missing pieces, and in these cases, I think it's up to us to build libraries to add in features like theming and responsive design. Let's take a look at how we solve these things for BeatGig. In 2019, this feature request for React Native support was opened on the Chakra UI repo. I thought this was pretty exciting because I wanted a library like Chakra for React Native and React Native Web with unstyled components. I ultimately decided to build my own library called Dripsy. Dripsy is a set of responsive, unstyled UI primitives for React Native and React Native Web based on a theme. This is what it looks like to use Dripsy. It's heavily inspired by Theme UI from React. On the left, we have our theme, and on the right, we can style a component using the SX prop. So I'll try adding a background color. And here it pulls values straight from my theme. If I want to make a value responsive, such as padding, all I need to do is pass an array. Here it'll use the third scale on mobile devices and 0 on any screen bigger than that. We now have a way to use theming and responsive design across platforms, creating a consistent user experience no matter where your users are. Next, let's talk platform-specific features. Every now and then, I come across a feature from web that doesn't yet exist in React Native. Two good examples are anchor tags for scrolling down a page and URL query parameters. Let's take a look at how we use these features in a cross-platform app, and then I'll show you how you can make your own. Something I love about HTML is how easy it is to scroll from one part of the page to another using an anchor tag. The issue is React Native doesn't have anchor tags. So to get around it, I built my own library called Anchor. Anchor lets you scroll to any arbitrary component inside of any scroll view. It works cross-platform with the exact same API. I've found this to be especially useful when a user submits a form and I want to scroll down to the errors. To the left, we have the BeatGig website, and on the right, the iPhone app. Let's see what happens if I submit the form with missing fields. Notice that it turns red and scrolls to the correct field. Let's do the same thing on the iPhone app, and the same thing happens. So I'll enter my offer amount here, and I'll do the same thing on the app, and I'll hit submit again. And now it takes me down to the date. So this time I'll set a future date, say December 2nd, and I'll set one on the app as well. All right, so I'll submit one more time, and it takes me down to performance length. So I'll fill this in, do it on both. And now we have the app submitting on both for offers to Loud Luxury. Here we were able to use anchors to nudge users along the way and make the form experience much more enjoyable, even when there are errors. Next, let's take a look at using URL query parameters across platforms. Something I find really cool is using query parameters as our React state. So I made a hook called useParam, which lets us do just that. What's cool is this hook actually works cross-platform. On web, it uses NextRouter to get the query parameters, and on native, it uses normal React state. Here I have a name and a set name returned by useParam, which works just like useState. The first step is to set the actual name of the query parameter, which in this case is just name, and that is pulling from the types up here. When I call setName, it should set it in the query parameters and use that as my state. So I'll try that here. And there we go. Now it's rendering this name, it's in the query parameters, and if I refresh, I maintain my exact same state. Let's try adding a clear name function. I'll just set the name to null, and then I'll add a button. All right, so I'll go ahead and click clear name, and now it's back to null. It clears that out of the query parameters, and there's nothing here. Now let's look at a more complicated example using age, which is a number. The reason this is more complicated is because age is a number, and query parameters are always strings. So here I have TypeScript complaining. The reason is because I need to parse the value in from the URL string. So in this case, I'll use the parse function, which gives you the value from the query parameters, and it expects you to return the type you want. So in this case, I'm going to return a number based on the query parameter I have. Okay, but why is this still upset? Well, what happens on the initial render if you don't set a value? You need to set initial, similar to useState from React. And there we have it. We now have an age query parameter, which is a number, gets parsed in from the URL, and also lets you set an initial value if it's undefined on the first render. To recap, parse works similar to a JSON parse, but you can do it by query parameter. Now, if I wanted to have a custom value in here, let's say it was number or hello. In this case, the H type is going to recognize that parse returns number or hello, but I'll just clear that out. And now age is always going to be a number. This is especially useful if in parse, you want to restrict users to only a specific set of types. For example, you might want it to be a number that's only 1, 2, or 3, and you can handle all that inside of parse. And that is it. This is probably the most useful hook I have, and it's so simple. It works just like React State across platforms, but on web, it lets you manage it all through your query parameters. Next, let's look at writing our own platform-specific code. To run different code based on the platform you're using, import platform from React Native. Using platform.os, you can distinguish between your platform and run different code. Typically, you'll want to provide a fallback for other platforms. Alternatively, you can import different files altogether based on the platform using a .platform extension on a file name. In this case, index.web.ts will be imported on web, and index.ts will be imported on all other platforms. And you can do this for as many platforms as you want. In general, I actually recommend against writing platform-specific code directly in your app. In fact, in the Modi docs, I wrote that using platform.os is an anti-pattern. If you find yourself needing to write platform-specific code, chances are you found a good idea for an open source library. Platform inconsistencies should be handled by third-party libraries so that apps can always build with a single unified API. Next, let's take a look at the monorepo structure for React Native Next.js app. The best way to structure a React Native Next.js app is with a monorepo. Here I have a packages folder and an applications folder. Inside of applications, I have my 2 separate entry points. Next is just my Next.js app, as you'd expect, and Expo is the React Native app that will run on iOS and Android. Expo provides a set of libraries and services that makes building and deploying with React Native super easy. While it isn't a perfect comparison, in many ways, Expo is to React Native what Next.js is to React. It makes shipping your product into production a way better experience. I highly recommend using Expo for the React Native side. I find this to be pretty uncontroversial. I won't spend too long on this. Instead, at the end of the talk, I'll link to an example monorepo, which you can use as your starter. With React Native, we have an instrument to turn ideas into component-based products quickly. Combine it with Next.js, and we can leverage the best features the web has to offer. But there's still work to be done. And if you want to take part in building the cross-platform stack of the future, I encourage you to follow and reach out to me on Twitter at Fernando the Rojo. I hope you enjoyed this talk, and I can't wait to see what ideas you have to keep pushing this stack forward. Thank you.
Welcome to another episode of Compressed FM, a podcast all about web development and
James,
design.
you know this isn't a podcast, right?
It's not a pod. What is this?
This is Next.js Conf.
Next.js Conf. You mean they can see
That's
me?
right. You might, want to check your teeth.
Oh, all right. Let's try this again.
Okay.
Welcome to our audio and video talk at Next.js Conf. We're really excited to talk to you about the tech stack behind Compressed FM, a podcast all about web development and design.
In February, James and I started recording a podcast all about web design and development. It's released every week, and you can find it on your podcatcher of choice, whether that's Spotify, Google, iTunes, you name it. Hopefully it's there.
A podcast, huh?
That's right.
All right. Tell me more.
That's right. We've recorded over 30 episodes. And we've also done 2 crossover episodes, one with the folks at Web Dev Weekly and another with the folks at Perfect Dev. We have over 25,000 downloads. We have 5 sponsors, and all of our sponsors are our favorite, but I do want to highlight one in particular, Vercel. And we are so excited to be here at Next.js Conf. Okay, that's enough about the podcast. Let's introduce ourselves. My name is Amy Dutton. I'm the creative director at Zeal.
And my name is James Quick. I'm the developer media manager at Auth0. And I figured I might be able to shed a little bit of light on why we decided to start this podcast. When Amy and I started to talk, we realized that we both share a love for teaching. We both feel like we have a lot of experience, a lot of knowledge that we really want to share with other people to help them grow and learn as well. And we also realized if we were going to start this podcast, if we wanted to build up an audience, if we wanted to help people, we would need to have a website, which we did not have. So Amy, do you want to tell people a little bit about the features that we thought we were going to want to include in the website as we built it out?
That's right. So like any good website, we needed a homepage. And on this homepage, we wanted to feature general information about the podcast itself, where it could be found in the most recent episodes. We also needed subpages to highlight all the episodes on the podcast, a page with the individual episode information, a contact page, a newsletter page so that people could sign up and also see previous newsletters.
And for all the designers out there, can we just take a second to appreciate this Figma board that Amy put together?
That's right. Everybody loves a good Figma board, or at least a good, well-organized Figma board. Another piece is we wanted to have a custom audio player that would feature all the bells and whistles. And some of those bells and whistles are deep links into an episode itself. So you can change the URL and it would jump to that specific place in the episode. It would also have jump cuts. So we could list out different chapter marks within the episode. You could click on that and jump to that particular section of the episode. Then we wanted a featured player that was a little bit bigger and larger on the homepage. For the newsletter page, we wanted to provide the ability for people to register as well as highlight all the information in previous newsletters. And then probably one of the features that I think James and I are the most proud of is our sponsor dashboard. We wanted a way for sponsors to be able to log in and see in real time how many downloads and listens each individual episode that they've sponsored has received. In addition, they would be able to see all the contracts and all their invoices. So what did we actually build?
Well, before we get into that, maybe we should start with the data. As we all know, data is the thing that powers websites and actually makes them functional and exciting and fun to use. So let's start there. We decided to host our podcast in Simplecast. So if you look inside of Simplecast, you can see all of our episodes are hosted there. In addition to hosting the actual episodes themselves, Simplecast gives us some analytics that we can follow about how we're doing in terms of downloads and listens and that sort of stuff. And that's really neat, but the next level iteration of that is the fact that not only is that data accessible inside of their dashboard, but through their API, we can make it available inside of our dashboard. So we've been able to integrate, as you'll see in a few minutes, with the Simplecast API to grab that listen and download information and display that for our sponsors so that they can see that and check how their sponsored episodes are doing. Now, that's just one half of the data that we have. That's for the analytics and the episodes themselves. But what about miscellaneous data? How do we keep track of sponsors and jump links and metadata associated with the different episodes? Well, Amy and I both have used Sanity.io, which is a headless CMS, in some of our personal projects in the past and have really enjoyed it and decided that would be a great option to go with for storing the data for our compressed FM podcast. So one of the things that's really cool and interesting about Sanity is you have the ability to customize your dashboard and your models and your schemas through code. So you can see here a quick screenshot of all the different schemas that we have for all of our data, which is actually maybe a little bit more than you would expect. And then this translates to inside of the actual Sanity Studio itself. You can see those are the different categories of models or schemas that we have. And then here you can specifically see the information that's associated with each episode, like a title, slug, date, sponsors, cover image, so on and so on. You can tell it's actually a decent amount of data.
So on the homepage itself, we needed to be able to pull in that information from Sanity to display general information about the podcast and the most recent episodes. So if you look at the code itself, you'll see a query here, and it's using Grok, and that's the query language that Sanity provides. You can also export that as GraphQL, but here we're using Grok. So we're asking the database for all of the information for each episode that has been published before now, and it will order those by date and provide all of the metadata around that specific episode. Then we're passing that information over to the layout. And the cool part about Next is we were able to create several different layouts, one for the homepage and one for the interior pages. So you can see here, our homepage is actually being wrapped in the home layout. Then we had to create a bunch of different subpage layouts. For the episode page itself, we used a query as before from Sanity to grab all the podcast episodes. And then I kind of glossed over this before, but we're using get static props so that this page renders as fast as possible. And then Similar to before, we are wrapping that with a layout, in this case, the interior layout for the episode page. And we're passing all the information that we got from get static props into our component itself. For the individual episode page, this is going to look similar to before. We're querying Sanity for the information, and then we're using get static paths and get static props. Now, the difference here is get static paths checks the database to say, hey, these are all the URLs and all the paths that you need for all the episodes. And then it passes that information to get static props so that it can get all the information it needs for each individual page. And again, this allows the site to be super fast. One of my favorite components on the site is the audio player. And one of the reasons I got so excited about this particular component was it not only proved to be a fun coding challenge, but it allowed me to have complete control over the design. So there are multiple players throughout the site. So on the homepage, we have a player that's large and in charge. That's a featured player. Then on the sponsor dashboard, which we'll talk more about later, we're able to highlight the actual sponsor ad read so that when a sponsor comes to their dashboard, they can see where in the episode their actual sponsor read is. Then at the individual episode page, we have a different player that allows the user to have a little bit more control over the playback itself. So you can listen to it at 1x or 2x speed. You can jump forward 30 seconds or back 30 seconds, and it just provides a little bit more control. And if you're interested in the specifics of the player and the code behind it, I actually have a whole series on YouTube where we break it down line by line. That's at Self Teach Me. So for the newsletter page, we needed to have the ability for the user to sign up, and then we also needed to display the previous newsletters. So there's some fun things that are going on with this particular page. We're querying it just like we did with the episodes page, but we're also using Sanity's portable text feature to be able to have control over each individual newsletter layout. So whether that's highlighting a full screen image or having an image on the right and text on the left, or vice versa, the portable text allows us to have that type of layout control within the Sanity panel. So this query looks a little bit different just because we are accommodating for portable text and how that information is being returned. But it's still using that get static paths and get static props to be able to render as quickly as possible. So for the newsletter itself, the form is actually pretty sweet. We are using Quez forms, which just so happened to be a compressed FM sponsor, but we were actually using them before they became a sponsor. And one of the reasons that we loved using Quez was it allowed us to create all kinds of integrations and do fun things on the back end without writing additional JavaScript and serverless functions. So if you go to the Quez form site, you'll see that they handle spam protection as well as built-in validation. And the validation happens on the front end in your browser, but it also happens on the server side. So there's no chance of malicious code being injected along the way. But it also handles local testing and multi-step forms. One of the cool ways that we're using these features is on the sponsor application page. So we're pulling information about all the pricing for each episode into the form and displaying that. But on the future episodes, it's checking to see which episodes haven't been sponsored yet and displaying those as options within the sponsor application. If you go to the Quez form site, it will tell you that using their form is an easy, simple 3-step process. You just add a class name to the form itself. You can add rules for validation as attributes to the input field itself, and then you include their script along with an action attribute. And it is as easy as this 3-step process. So if you look at our code, we are using a use effect to initialize the form. And then on the form tag itself, you'll see we have that action tag. Each of our inputs have a unique name attribute. And that's really all there is to it. It just works out of the box, which is pretty sweet. Now, Quez Forms has several integrations that they provide, but we are actually integrating with Zapier. And one of the reasons that we're using Zapier is it allows for multiple steps to happen after the actual form is submitted. So for example, the newsletter, it just gets passed off to MailChimp. But for the contact form, one of the things that we're doing is I get a message in Slack directed towards me, but then it also checks to see if the user wants to be added to the newsletter, and it will add them to MailChimp as well. One of the reasons why we went with MailChimp was it was a more cost-effective solution, but it also allowed us to customize the newsletter itself with their built-in tools. We're also making use of their journeys feature, so different things will happen depending on which form you fill out. If you are a sponsor or a guest, you get a unique thank you message sent from MailChimp, or if you join the newsletter, you get a unique welcome message that way as well. Then I just wanted to throw out with Next, we were able to achieve a perfect Lighthouse score without much effort.
So let's talk now about the dashboard. And I think this was maybe in comparison or in addition to the audio player, like one of the most intricate pieces that we have in the dashboard, because we need to make sure that only certain people with certain emails should be able to access the appropriate sponsored dashboards. And then we need to integrate with Simplecast and our API data and all that sort of stuff. In addition, we wanted to show the relevant invoices and contracts and episodes that are associated with each individual sponsor on their dashboard page. And as we started thinking about how to best protect our application, we started wondering what's the best way to do that. And we're a little biased because I work at Auth0, but we decided to give Auth0 a shot. And in fact, this was actually Amy's first time ever using Auth0.
Yeah, I did just want to throw out there that I obviously have a connection to Auth0 through James, but it was so easy. It took me about 5 minutes to set it up myself. Originally, the plan was that James was going to help walk me through it, but I jumped the gun and did it myself without any trouble at all. So if I can do it as a designer, then you can definitely do it.
Don't let her fool you on her development skills, but we did decide to use Auth0, and we used it for a couple of different things. We used it for authentication of handling the login process and deciding who is this user. And then authorization, the difference here is what does that user have access to, which is actually really important. And we'll talk about that more in a second. Auth0 actually also does the user management for us so that we don't have to. And then it has really nice integration with SDKs like the Next.js SDK that you'll see here in a second. So that Next.js Auth0 SDK is on GitHub. You can go and check it out. You can try it yourself. And once you do, after you configure a couple of environment variables, you'll be brought to this screen where you'll need to export this handle auth function. And that's really all the configuration that you're going to need. What this will do is it creates a dynamic route for you, which behind the scenes then generates the associated routes for login, logout, callback, and me. Login and logout are probably self-explanatory. The callback route is the API route, the serverless function that gets called after the user redirects over to Auth0, logs in, and then comes back to our application. It calls that callback function where you can add custom logic if you want to. The me route there is just if you want to call that route and get general information about the user, that's what that one is there for. So with those in place, if you go over to the code, if you want to add a login button, what that becomes is just a link to the logout or login routes. So you can see here that we are conditionally displaying login and logout buttons based on the user themselves. Now, one of the things that Amy did as a designer that I thought was really, really cool is she customized the universal login page for our application. This is a login page that's actually hosted in Auth0, but as you can see, has our brand waveforms in the background and then our strong black and yellow colors on top of it. So it really looks like it's natural to the compressed FM brand. Now, we talked about trying to protect certain pages for our dashboard to make sure only the right person could get there. Well, you can start with exporting this with page auth required thing that comes from Auth0. And what that does is it automatically checks to say, hey, if a user is trying to access this page and they're not logged in, it's going to redirect them to the login page. So this will make sure that the user is authenticated, but this doesn't make sure that the user is authorized to have access to that page. So what do we do next? Well, you can actually customize this get server-side props function and add any additional sort of logic that you need. So for example, what we did is we were able to track associated emails with a different sponsor inside of Sanity. So as we onboard a new sponsor, we can grab an email address from them, add it to the associated emails property, and then be able to check that as a user logs in to that specific page. So we have different pages, dynamically generated pages for each sponsor. And then inside of this custom get server-side props, we can grab the user that's logged in. We can grab the email associated with that user. And then based on the URL or the slug for that sponsor, we can go and query from Sanity to get all the information about that sponsor that the user is trying to access their dashboard for. After we have that sponsor by slug, we can check the associated emails and see if that associated email includes the email of the logged in user. or see if it's one of our admin emails so that Amy and I kind of have a backdoor so that we have access to all the dashboard pages to go and look and make sure that things look good as we're testing. So after all of that takes place, we're able to allow the user through to the dashboard where we will display all of their information. Inside of here, you can see not only do we have all the information that comes from Sanity about the sponsor, but then we go ahead and iterate through each one of their episodes and interact with the Simplecast API to grab the associated download and listen information as well, so that they have all the information they need right inside of that dashboard page. All right, so that was kind of a lot. Let's do a quick recap here. Amy and I decided, based on our love for teaching, that we wanted to start a podcast. Because we wanted to start a podcast, we then realized we needed a website. And not only did we want a website, but we wanted it to be kind of impressive. We wanted it to be as good as we could make it. So not only did we do static pages for our homepage and our episode landing pages and all that, we have integrations with Sanity for all of the metadata that we need. We integrate with Simplecast to store our podcast episodes and get analytics from. Amy built out a really sweet custom audio player that has lots of functionality. You should go and check out that video series on her YouTube channel. Had really cool integrations with Quez Forms and Zapier and MailChimp to handle our newsletter and onboarding stuff. And then lastly, we built out a custom dashboard with Auth0 to help protect our application before we display only the appropriate information for the appropriate sponsor based on the user that's logged in.
If you want to check us out, please go to your podcatcher of choice and search for Compressed FM. And if you enjoy it, and only if you enjoy it, please leave a rating and review. It really does help the algorithm and give our podcast a lift, helping other listeners just like you find our podcast. If you want to connect with us directly, you can find us on Twitter, James at JamesQQuick, and myself at SelfTeachMe.
That's all we got.
Hi there, Tim from Checkly here. Today I want to talk to you about the performance and reliability of your modern web app. More specifically, I want to show you how you can use a new generation of headless browsers to catch common performance and reliability issues all before you go live in production. If this sounds a lot like end-to-end testing, then you're right. But end-to-end testing is a little bit boring. It used to be flaky, right? Well, it kind of used to be. But stick with me, and I will show you why I honestly think that we are entering a golden age of end-to-end testing. What's important to notice is that performance and reliability are top of mind among JavaScript devs. In the recent Jamstack community survey of 2021, performance, and in this case, uptime, were the number one and number two concerns for devs when building a website. This talk is going to be very practical. I will talk you through some code examples that you can run yourself using Node.js, Playwright, my headless browser framework of choice, and GitHub Actions. All of this code is available on GitHub in the link below. Essentially, I'm going to show you how to build a mini Checkly, because at Checkly we run millions of these headless sessions per month. So no need to sign up to any servers right now, except GitHub, to get your feet wet and start exploring. Of course, at the end, I will do an obvious pitch of how great Checkly works in this context and how it deeply integrates with Vercel for all your Next.js projects. Let's dive in. Here I have a very basic Next.js project using Next.js 11. This should be bread and butter to the most of you. Now, we wouldn't want this super enterprise level website to be shipped to production with catastrophic bugs or terrible performance, would we? No, we wouldn't. So let's introduce Playwright to make sure that this doesn't happen. So what is Playwright? Playwright is an open source framework developed by Microsoft that enables you to talk to a browser from your code. You can click on buttons, fill inputs, take screenshots, and much, much more. Playwright itself is written in TypeScript, so it plays very well with the JavaScript ecosystem. However, it also supports Python, Java, and .NET. What sets Playwright apart from other similar frameworks like Puppeteer and Selenium
are its speed and its smart features like auto-weighting for screen elements to appear before clicking on them. Okay, let's write our first Playwright script. Here it is. It's a simple JavaScript file that I put into the end-to-end test directory. Just step one. And this is my whole Next.js codebase for the project I just showed you. So let's run through it and see what it does. Well, firstly, we install Playwright. In this case, I'm installing Playwright Chromium just for demo purposes because it only downloads the Chrome browser instead of Chrome, WebKit, and Safari, as Playwright supports all of these three browser platforms. Then we have a small run function, an async function, so we can run the await code. We create a browser, we create a page. And then we set a target URL variable. You will see that it uses a target URL environment variable and a hard-coded production domain name. And I will show you why that is and how it comes in very handy later when we run this in GitHub Actions. So we go to our target URL with the page goto method. We click on our button. We snap a screenshot. And then we close the browser. That's it. So let's run it. It did the thing. It opened our target URL, in this case localhost, click the button, snap the screenshot, close the browser. Let's have a look at the screenshot. Amazing, it worked. Now let's get some more data from that Playwright script and create a little report on reliability. Okay, here's the rundown. I added a report object here with a bunch of counters that will record some key metrics that happen throughout our browser sessions. We have properties for all requests that finish with a good status code, so anything up to 399. Then we have all the requests above 399, the bad ones that fail. Then we have a failed request counter. This is just for requests that error out on the network level and never respond. And then we have a counter for console errors. This could be anything, your own JavaScript erroring out, some third-party library, or some malformed JSON response confusing your code. And we collect this data by listening to events emitted by the Playwright page instance. You can see that right here. We have some listeners on request failed, on respond, and on console. And every time we do a little console log, and we bump these counters. So all the way in the end, we just log this to our console, which you can see right here. And that's our little reliability report. Let's give it a spin. Oh my God, we have some errors. We got console error lines. You can see that right here, 2 of them. And we got a failing request also. And we have 11 normal requests that failed with a status code lower than 399. And what you can see that apparently we had some requests to some servers with a non-existing domain name. What's interesting also is that none of these errors were actually obvious when we snapped that first screenshot. So in this specific case, the image was at the bottom of the viewport and it was missing, and you can see that right here. So there is a broken image. Okay, let's add some performance metrics. In our case, I want to add some web vitals. Again, we create a data structure to capture these. And we're going to capture the web vitals FCP, or first contentful paint, and LCP, the largest contentful paint. We use a Playwright feature where we can directly inject a script into the page. And in this case, we're injecting the standard web vitals library that I just installed using npm. Note that we're only interested here in web vitals that make sense in a lab or synthetic environment, opposed to the web vitals collected in the field using real user traffic. For instance, what Vercel gives you with their analytics feature. So you can see a bunch of code here that essentially calls the library that I just injected and then adds the metrics to this little object. Again, we console log that object at the end of our script. Let's give it a run. Here we go. So we got the same errors, of course, as the previous run, but you can see that we added the first contentful paint and the largest contentful paint, and we logged it to our console. So how do I run my end-to-end script on each deploy? Well, there are many services offering this. Hint, 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 we at Checkly do that, but you can run this from your continuous integration setup. We will use GitHub Actions for this. As you can see, this file, I added it to the standard .github/workflows directory, and it's pretty standard actually. Let's walk through it. It targets, first of all, the Node.js runtime, and it checks out our code. It does a little setup, then it installs our dependencies, and then it runs the end-to-end test command from your package.json. But there's three things to note here. Firstly, we only trigger this action when GitHub receives a deployment status event from Vercel in this case. Then we check if that deployment status is actually successful. Lastly, we assign a target URL parameter that comes with the deployment event and assign it to a standard environment variable so we can read it in our script. You already saw that when I ran our tests against my local host. In this case, we're going to get the preview deployment and the production deployment URL given to us by Vercel, injected into the script, so we can run our end-to-end test against all the preview and production deployments. So what does that look like in practice? Well, of course, I ran a little bit earlier, and you can see it right here. This is our script, and here is the test step. You can see what happens. We get a target URL that is specific for this commit. It runs through our checks, and it prints the same info that we saw earlier. In this case, the GitHub action passes. We could add a little exit code to the script to make sure it fails, send you an email, or otherwise trigger something in your PR review to know like, hey, this thing broke, I need to take action. What I just showed you is of course just the tip of the iceberg. Playwright allows you to script and test much more complex multi-step flows and extract a lot more data. And we do this at Checkly to check our own web app. Here's what that looks like on the Checkly dashboard. This is a multi-step Playwright script that logs into Checkly and navigates some key pages. We run these tests against our staging and production environment on each Git push that Vercel deploys for us, so not against a mocked environment that runs inside some CI pipeline. This gives us way more confidence that what we ship actually works in real life. What's even cooler, we also run the exact same set of scripts every 10 minutes against production. Two things to note here. All the Playwright instrumentation and collection of metrics is done for you automatically. We also automatically snap a screenshot for you when an error occurs in your Playwright script. And second, we now have a great integration with Vercel that can automatically block your deploys if any of these tests fail. If you want to play around with this, sign up for a free forever plan over at checklyhq.com. So let's take a step back. I mentioned at the start that I think we live in the golden age of end-to-end testing. What do I mean by that? Well, I mean that there's a convergence of three things. First, accurate preview deploys on each commit by companies like Vercel, Netlify, and others. Second, cheap, fast, serverless, Docker-based, or other ephemeral infrastructure resources. Third, of course, this new generation of snappy and easy-to-use headless browsers. Together, they make shipping reliable and performant web apps a ton easier and cheaper than it used to be. That's it for me right now. I hope I gave you some cool insights. As mentioned, this is just the tip of the iceberg. Visit playwright.dev for a ton more info on Playwright and checklyhq.com/learn/headless for an extensive set of guides on how to use Playwright in the wild. Thanks for watching. Bye bye.
Hi everyone, thank you for joining me today. My name is Michelle Bakels. I'm a program director at G2I, where I work on community-focused solutions for developer health and preventing and recovering from burnout. And today I'd like to share with you my experience building for nonprofit communities with Vercel and Next.js. And to begin sharing that experience, I'd like to introduce you to the community that I've been working with for the last several months, and that is 1909. 1909 is a community in West Palm Beach that is for creators, by creators, dedicated to the holistic growth of entrepreneurs, creatives, freelancers, offering workspace programs, resources, and events for the like-minded who give a damn about building a better tomorrow. And if that sounds like a very ambitious statement, it is. However, I promise you it has all of the impact and punch behind it. And 1909 is one of the most incredible communities that I've ever seen, let alone had the fortune of being a part of. And what makes it so great is, of course, the amazing people who are the members of 1909. So to tell you a little bit about who we are content creators, marketers, bakers, gardeners, economists, activists, musicians, inventors, yogis. The members of the 1909 represent a very diverse array of skill sets and talents. And I think on a higher level, you could really describe the members of 1909 as creators, freelancers, startup founders, entrepreneurs, and first employees. So there is a lot of experiences that we share with each other. We help each other through the struggles and the hard times. However, we also are there for each other for the wins and successes that we can celebrate together. And so it's really a great community. And if you have ever been a startup founder or an entrepreneur or been close to someone who has, then you'll know that there are some pretty big struggles in that journey. And one of them, I think, is when you're starting early on, you have to wear 10,000 hats because it's typically just you or you and a couple of people. And so if you're like Enuela here in the bottom photo, you may be really passionate about teaching kids how to grow their own food at home and educating them on nutrition. However, you'll find yourself also doing the bookkeeping and the social media posts and advertising and a million other things that you may not be necessarily very good at. And so one of the things that we want at the 1909 for our members is the ability to stop doing the things we're not good at so that we can focus on the things that we are good at. And we already have at the 1909 this culture of giving towards each other without expecting anything in return, and the mindset of going further together. So with that known and with that already in practice, the team at 1909 got together and came up with a plan to create a platform to facilitate, innovate, and incentivize on this relationship that our community already has amongst each other. And so we got together for a collab day, which is essentially kind of like a startup hackathon in a sense, where we fleshed out the idea for the exchange, which is a platform that has a feel of a task board crossed with Venmo. And it would be where our members could post things that they needed help with, and someone could basically pick that task up in exchange for a couple of tokens, which they would then be able to use again on the marketplace to get something done for them that they need help with. So it was a really cool idea around gamifying and incentivizing something that already occurs, and just making it a little bit more robust for our members. We also had the opportunity here to collect data around the activities of our community, which was really important as a nonprofit community. There is quite a bit of data that we can collect. However, insight into the everyday as a member of 1909 can really help with grant proposals and when you're speaking with donors. So for example, imagine being able to say in Q1 of 2022, our members exchanged $40,000 worth of services amongst each other in support of growing entrepreneurs and small businesses in West Palm Beach, Florida. So that's a pretty powerful statement to stand on and to be able to speak to when you are running a nonprofit community. So there was a lot of incentive to put this platform up. So we came up with a game plan to find developers to work on the project, design and build the MVP, and then iterate as we received feedback. And this is all pretty straightforward, typical for developing a project. And so we began on the first iteration where we built a simple transaction application with a React front end, Node back end. We invited any developer to work on it if they wanted to. It was really an open invitation. And we used the simplest tools and languages that we felt that anyone could work with. They would either likely already know it or they could easily pick it up. So, despite like some of our best intentions here and coming up with what we thought was a pretty straightforward, simple plan, there were some unexpected bumps, specifically with doing extra work on the side or volunteer work outside of your normal 40-hour work week. So what we learned is that the company MVP is very different from the community MVP. So if we were building this in a company, it would actually probably be considered pretty trim. However, for side work, we really needed to narrow it down even more. We created too much to maintain outside of the most critical functionality. The most critical functionality was the actual transactions. However, we did end up wasting quite a bit of time trying to get this profile image uploader to work that we ended up scrapping. So things like that didn't even contribute to the actual functionality of the transactions, we had to really pare down. Everyone's spare time is different, so we needed to ensure that we could async everything, if not as much as possible. And then probably one of our biggest pain points was building and deploying created too many unexpected blockers, especially when we were onboarding our developers. So this is just a common wall that we would hit when we were bringing in developers or setting people up, was that the platform that we were using was just a little complicated, especially if you didn't have experience with it. So our takeaway here was that every process that left the potential for significant time loss risked A, completely losing a developer or volunteer for the project, or B, delivering on the project at all. So since time is so valuable with volunteer and side work, we really didn't have hours to waste on anything, because a couple hours wasted can put delivery back a week or two when we were talking about doing things on the side. So we went back to the drawing board and we came up with a new iteration that was way pared down called Skillshare, which we're still working on the name. But in any case, we designed it like it was an MVP for a hackathon. So what can you deliver in 24 hours that works? And 24 hours of volunteer time is actually quite a bit of time. So we also wanted to make sure that we got strong commitments from a small group of self-starting developers. So it was, before where we would ask, like, oh, would you like to work on this? Yes. Now it was, okay, what time exactly do you have to spend? What do you intend to take ownership of? When do you think you could deliver this? It was a much more explicit conversation. So I take that on myself. The open door will be great to revisit again once we have the MVP done. However, in the beginning, when we're just trying to get it out there, we have to close that circle. Async everything as much as possible, from communication to development to planning, and of course prioritize removing processes and the potential for time loss. So we needed to recognize where we were losing time. Sometimes that's on code and it's inevitable, and you just have bugs and you have issues, and it's part of being a developer. However, there were some processes, especially in our deployments and builds, that we kept hitting issues with, and that was a moment of, okay, let's reassess this and figure out what we need to do to not make this such a problem anymore. So we had another collab day, and we decided to try and execute on this new game plan that we made. And for this collab, I kind of just woke up in the morning and decided to start working on it, and made a plan to essentially set up the foundations and the structures for our new apps, because it was really a whole app ecosystem that we were restructuring. Skillshare was a part of it. And I wanted to set up the builds and deployments for these apps as well. And so since we were starting from scratch again, more or less, I wanted to take a look at Vercel and Next, because I've heard so many good things about Vercel and what they offer. And so I allocated about a half of a day to learning Vercel, or at least starting to, and was very pleasantly surprised that I only needed about 45 minutes. The tools were unbelievably simple to set up and use. And as soon as I deployed our first project, I realized that this was the answer to one of our greatest pain points and time wasters, which was our builds and deployments. So that was really great. I could simply add other developers to our team. We didn't need to be installing anything and debugging console log statements. It was very, very straightforward. And with Next, it eliminated our need for 2 of the backend repositories that we were planning on setting up and using for these apps. So yeah, I mean, I really enjoyed using Vercel and learning it, and being able to integrate it into our work with this nonprofit community. And I think just the whole process was just so unbelievably simple. I still get really like all of those same feelings of like happiness and excitement and relief when I think back on that day and that moment where I was like, wow, this really is so easy. And it's funny because I tell people the thing that took me the longest was looking for the rest of the instructions, because when I was first using it, because of my experiences, were just in complete disbelief that everything I needed was in one UI. And so I actually started searching around the internet for the rest of the instructions on how to deploy on Vercel. And of course, it was really as straightforward as it seemed. And so at the end of the day, what I was actually able to deliver was the foundation for these apps, the builds and deployments for all of them. I was also able to get our developers onboarded and then spend the rest of my afternoon actually writing the code, which is the thing that we really care about, and the part of these projects that we really want to do is delivering the value and the features for our community. And I was able to build 2 front-end apps completely, one of them being the Skillshare, and get those deployed so that moving forward, we just start working on the services. So really exciting day, and was really great to share with the team, and they were all really excited too. So comparing our previous experience to using Vercel, again, our last platform wasn't really even too terrible. A lot of it was just expected in the developer experience. However, once you use Vercel, the bar gets raised really quickly. So with the previous platform, it required a CLI install, and that's fine. That's really common. However, the error messages were really difficult to decipher, even for experienced developers. If you weren't familiar with what those error messages were really trying to tell you, you could be debugging that for a while. No automatic builds and deployments by default, which is nothing I ever expected in my life. However, once you have a taste of that life, then you can't go back. We had longer builds and deployments, again, something that I just accepted as par for the course. And at times, the documentation was really confusing and differed a lot from our actual experience with trying to follow that documentation. So again, this is, something that I really would have always considered part of the developer experience. However, switching to Vercel, where we could connect a repo, create a team, build and deploy an app in one UI in about 5 minutes, really changes the game. We also had automatic builds and deployments by default, which it's just like a dream to me. The UIs don't require documentation, which is fantastic. The page works the way that you expect it to. And the documentation doesn't require Google and Stack Overflow. So for Vercel to be the creators of the product and to be the best source of information on how to use that product is a little bit more rare than I think we like to admit when we're using software products in our programs. So yeah, I was overall very impressed with the developer experience, completely understand what all of the hype is about around using Vercel and Next, and was really happy to make the decision to move forward with using it in our project. So where are we now and where are we going? We have a core team of developers, which is awesome. We're moving forward with our new apps built with React and Next and Vercel. And we're going to begin testing with our community soon. We don't have an exact date yet. However, our roadmap to testing is pretty short at this point. So we're getting really excited. And I also wanted to give a quick shout out to the dev team that's been working on this. Rue and Becca, thank you so much for picking up the torch and running with this project. Andres, the original 1909 developer and the creator of the blueprint for gamification software at the 1909. It's been awesome to work with you on these projects. And then, of course, Ryan, who's really kind of the visionary, innovator, pusher of the project, very dedicated to this idea of creating the skill trading platform for the members of the 1909. And it's been incredible working with you. And of course, there's a ton of people to mention that aren't listed here. It's really a community effort to put this out, but really wanted to make a special thank you to the team that I work with and talk to about this on a day-to-day. So with that said, thank you so much to the dev team that I get to work with. Thank you so much to Vercel and the team there for creating amazing developer tools and experiences. It's again just a game changer for us, for the industry. The bar has been raised. You set a new standard. So we are really excited to continue working with your tooling and seeing what we can do. And of course, thank you everyone for joining me today for this talk and hearing our story about how we build for nonprofit communities using Vercel and Next.js. Thank you.
Hello everyone, I am Ahmad and I'm super excited to be here for the second time on the Next.js conference stage. And today I'm going to be talking about building the developer relations stack entirely with Next.js. But before we go ahead and jump into the details of that, how about I introduce myself a little bit so you know where I'm coming from and why I'm building everything with Next.js. So I am an award-winning open source engineer. I've been writing open source code for over 10 years now. I've written hundreds of projects. A lot of them are CLI. One of them is a Shades of Purple code theme or a Corona CLI. And millions of developers are using my code, which is a humbling feeling I cannot even explain. A really teeny bitty, bit of a code that I actually contributed to open source ended up on Mars. So I think I can claim the status of being a Martian, right? Anywho, I am a Google Developers Expert, the recipient of 8th GitHub Gold Star Award. And I've been around the blog. I'm really excited about the web platform. I'm a web purist. And the fact that Next.js is building the next generation of, sort of like software development kit for web, it just excites the hell out of me. I also love to teach developers. If you go to nodecli.com, you can learn everything I know about JavaScript and automation to build your CLIs. Or if you go to vscode.pro, you can learn from me how to become a VS Code power user. Right now, I'm working on a Next.jsbeginner.com course which I'm super excited about, but let's hope I can finish it in time for next year. As far as my day job is concerned, I'm part of the executive leadership team here at Rapid API. As their senior director, I'm the head of developer relations. We are like about 5 or 6 people in DevRel right now, and I'm still hiring. If you go to avast.dev/hiring, you can read all about that. Everything we are trying to do here in the developer relations team is based on Next.js. And there are very much, super valid reasons of why I have chosen Next.js to be the entire core of our DevRel stack. And that is exactly what I want to talk about today, building your developer relations stack with Next.js. In case you don't know what developer relations is, it's like this really awesome field where you can be a teacher and you can influence the improvement of developer experience around the entire chaos that exists in building literally anything. If you're building anything, there's one service that is broken, there's this language that is just not working, there's this entire chaos that we work with. And services like Vercel and frameworks like Next.js actually help us improve the entire developer experience, kind of master that chaos around what we feel like when we are, as users, developers, we are sitting around and building something. Same thing we do for APIs here at Rapid API. And since I joined Rapid API, one of the things I really wanted to do was explain and teach APIs in a different manner. So you see, there is Rapid API Hub, which is the world's largest hub for APIs. We have 35,000 APIs and over 3 million developers are using these APIs. So you can consider it like a hub, just like GitHub, but for APIs, yet you can also sell APIs there and make a lot of money, right? So there's business involved in there. So one of our products is a Rapid API Hub, where developers go to list their APIs or to use APIs listed by other developers. And then if a developer wants to learn this thing, what they have to do is either they are left with our documentation or our API reference. There's nothing there in the middle where eager developers or discerning developers could go beyond the product or the documentation and learn through either interactivity, through videos, or whatever their preference is. So I, along with my team, decided to build something what we are internally calling a DevRel stack, a bunch of products built inside DevRel, which influence your learning, the entire learning platform, and the knowledge you attain as an API developer. This platform that we are building with Next.js does not only help you master what an API is, but it actually helps you improve that chaotic experience into an improved developer experience when you're either trying to learn or build something. Here's one of the projects, as you can see. This is not production ready right now. We are hoping to launch it on 1st November. But what you see in front of you right now is what we call guides, right? These are interactive guides filled with content that you want on a particular topic. But the fun thing about it is that they use a lot of interactive components. As you can see right now, this project is actually in its infant stage. There are community members like Saad and our DevRel team member like Pratham are currently building content for this baby project right now that we have. What we are building here is this interactive content, but either smaller or longer form of content that is based on one single topic. While this might just look like a blog to you, there is a lot going on behind it. This is based on SSD. This is mostly static content with a flavor of client-side rendered components that actually help you improve everything that you're trying to learn. For example, OpenAPI spec, right? And everything you see here is powered by Markdown. So all of these are either React components, and most of the content writers, that people who are writing content, is coming from Markdown. And while this might look like a random blog to you, the technology that's powering it, the read more, the relative suggestions that is coming from here are all based on Next.js. And there's a particular algorithm that we have been able to build. We are using Next.js image component here and the script loader, which has made the entire experience really useful, and the real user experience has improved a hell lot. It's not just that. Using Next.js, the script component, the images, optimized images, in everything, it kind of builds this entire productivity stack for writing content, where your content not only looks good, feels good, is interactive, but also has a really good SEO power or SEO juice in it, because Next.js, the script component, especially the script component, takes care of a lot of things for the core web vitals, the new Google, SEO ranking parameters, or the parameters on how Google actually measures the real user experience, where something like Vercel analytics also come in. Another project inside this DevRel stack is our video LMS platform, which is also based on Next.js. As you can see, a lot of really good community members like Arian, JavaScript Mastery, Jessica, Siraj, CourseTecher, Jesse, Catalin, and a lot of members have actually gone ahead and produced excellent quality content on turning your APIs into a startup and selling them on Rapid API. What we wanted to provide our developers who are trying to learn this skill from the get-go is this kind of experience where they can see everything in different modules and learn it in the way they prefer. So now what might look like a simple video embed to you, Next.js actually helps us derive this kind of new experience around learning that, enabling us to distribute the content in different modules and helping users mark particular module as complete, as you can see at the bottom here. All of this is being built with Next.js, and the core that powers this is actually Markdown. So if you have a video, if our developer team creates a video, they can actually use a simple Markdown file to split that video into different modules, not only host it on YouTube, but also host it on our particular platform to own that part of the content. And the fun actually doesn't really stop here. What I've shown you is just part of this particular monorepo, different projects that share different components. And this right here, what you see is an interactive guide, a learn platform that we are building. For example, if you're trying to learn about HTTP and different methods like the post request, a user, a developer can not only just read about it, but if you go down here, you can see you can play around with this interactive component. So if I zoom down here, a developer could come here, learn the post request method for the first time, and create different kind of data through this particular interactive component. As you can see, the response body includes my name and my job through the small, tiny little interactive component right here. This helps you learn by doing. And at the bottom, as you can see, there are quizzes and all of this information that is actually helping developers learn in a really good way. We've also tried to gamify this experience at the dark and light modes, which look really awesome and are super easy to do with Next.js. And the moment I move to the next lesson, you can see the post request lesson has been tick marked as complete, as something that you have actually learned. And you are able to not only just read about it, you are able to send requests and understand this particular part of API development in an extremely deep and careful way. And this is exactly what we are trying to build with a bunch of different things. This is not documentation. This is like a stack that is sort of like projects-based learning, where Next.js has helped us produce this really performant, blazing fast experience around something which is not documentation. It's sort of like courses and ebooks mixed together on the web platform, shown to you in different manners. For example, here is this React component, which is taking a bunch of data from our Rapid API Hub. So this is Rapid API Hub, and this is a particular Crunchbase API listed on it that you could use. As you can see, the latency and service level this particular API offers. On our DevRel stack, what we can do is whenever someone mentions this, it renders as this particular React component with this information listed there on the client side. Some of it is on the client side, some of it is server side rendered, and some of it is, for the sake of SEO, completely statically generated. In case you want a review of what that is, we are using CSR with Next.js to load components that are where we just render a small page with no dynamically loading data. You see a loading state, and then the page displays everything using an API. For some other pages, we are using SSR. Mostly these components are the components where we want to authenticate some part of the workflow, where the API is either non-existent or either the API is only internal. For example, if you want to create an account on Rapid API Hub and do send a particular request to a particular API, instead of doing all of that, we can authenticate your request through a particular server pipeline using the SSR server-side rendered pages in Next.js. And now without even authenticating you, we are able to show you a sandboxed experience of what it feels like to either sell, host, or use APIs that are hosted on Rapid API, right? And SSR is super helpful there. But there are also documentation pages here, as you have seen in guides or in the LMS, where the SSG static site generation comes in super handy. For the basic part, the static site generation is the server generates the entire website for us. There is like no dynamic data for the client side to process. But there is also incremental static regeneration, where, as you know, we have like 35,000 different APIs, and we want to build documentation or information site for that. We are able to use ISR for that. In our DevRel stack, we are using incremental static regeneration in a very creative way. ISR, or incremental static regeneration, is where you can use a fallback true parameter. And what it does is the server generates the page defined on a particular path on the build time, if that path particularly exists in your source code, right? And if that path does not exist, what it does is shows you the loading state, sends a request to that particular API, generates the JSON, and hydrates the data for you at that particular instant. But the second time you visit that particular page, it now has a static cached copy of that particular page, right? You see, I never really liked the fact that all of my images in Markdown is hosted with the code repository. While it's easier and fun, there is no database that you need to care about. It's more secure per se. But for content writers, or if you are that particular content writer editing a particular post, you have to worry about downloading all of those assets and all of the GitHub repository. And it's just kind of a big mess when you're trying to just add a blog post inside of a GitHub repository. So what we have been able to build is a module that we plan to share with you folks soon, which allows us to actually keep our images, data, all of the data in a separate GitHub repository, and all of our code, including a monorepo based on Lerna that Vercel supports, in a separate GitHub repository. So if you are part of the marketing team or content team writing content for this particular stack, all you really care about is Markdown files and images. You do not see any of the code. But if you are a programmer, if you're trying to improve this UI, as you can see here, if you're trying to build new ways of interactive content that developers are going to use, you only care about the code, not the data, not the images or Markdown or what have you. And that is a fun part. Like, our build script is able to generate a JSON API at the build time, and as soon as someone visits this page, using the ISR method, we can also use a fallback for new guides, for new things that our content writers are writing in a completely separate repository. And that, folks, is a whole lot interesting. And that is like, things like these are what makes me super excited about the future of web development with something like Next.js. And just like that, with CSR, SSR, and SSC, we are able to build an activation developer stack. So you see, millions of developers are already consuming our content, but this stack is actually activating them, allowing them to learn by example, learn by doing, or learn by watching, or whatever their preference is. We are able to render things on client side, or we are able to creatively use the ISR method to bring data from different sources into a particular single GitHub repository, which is completely separate from code. I'm personally really excited about all of the things that Next.js has enabled us to do without ever worrying about, image optimizations, Webpack configurations, or anything really. We have this entire stack in TypeScript, and we don't worry about our TypeScript configurations because Next.js has kind of tucked those configurations away from us, so we can focus on building awesome projects like this. I am really excited about what we are going to launch early next month here at Rapid API using Next.js. If you're excited about something that I have presented, if you have more questions, you can reach out to me on Twitter. I'm mostly active there at Mr. Ahmad OS. And I'm really excited about the future of web per se, with all of the creative components that Next.js have made super, super simple through all of this innovation in just the last couple of years. A small team here at Rapid API is able to build massive projects like these without a lot of effort and with an excellent developer experience. We are building our entire developer relation stack with Next.js. And if you're interested in something like this, go ahead and visit awares.dev/hiring or reach out to me on Twitter and let's be friends there. I've seen developers think of Next.js as this one single thing. It's either built for static sites or for dynamic sites or for only web apps. But as you can see, it's not Jamstack. I completely believe it's much more than Jamstack. It's Jamstack and beyond Jamstack. You can not only build your entire landing page, your blog, your marketing stack with Next.js, but you can actually try and build your SaaS app, your actual application with Next.js. And that is exactly what I kind of predict is going to happen next. We are going to consume the entire documentation stack with Next.js, and then our marketing side in parts of different products that are based on web, right? Using Next.js. If you have any question related to that, and if you're excited about what we are building, reach out to me on Twitter. And with that, I hope you had fun. I hope you enjoyed my talk. Take care. Bye. Peace.
Hey everybody, my name is Nick DeJesus. I am so excited to give this talk pitching the Jamstack and its ecosystem to your clients. A little bit about me. I'm a developer experience engineer at Prismic. I like all things related to e-commerce, Stripe, and how devs make money building sites, which is actually what this talk is about. So if you're here already, you're signed up for Next.js Conf, you're probably already aware of the Jamstack. You probably already love the Jamstack. We love the scalability, the security, the performance, and everything else that comes with it, the entire ecosystem. However, how do we sell the Jamstack to others? So this was a really fun talk. It's actually a joint talk. Well, I'm the only one speaking, but I got some help from Dan Spratling. Dan is a front-end developer, freelancer, and founder of Skyward, a virtual agency focused on Jamstack development. And I also had the pleasure of speaking to 4 other successful agencies: Jono at Roboto Studio, Hayden from Jelly Pepper, DJ and TJ from Monogram, and Pablo from Somos Gente Digital. So let's start off with, how do you find your clients? A lot of them get their clients from referral systems, from other Jamstack specialists that find clients through social referrals and direct contact, asking specifically about Jamstack projects. Putting out ads on specific use cases. They'll get clients from people looking to leave other platforms. They're not very happy with their plugin ecosystems or website performance. And some businesses are looking to get away from expensive hosting, situations where maintaining and upgrading is a nightmare for them. And then there's the good old-fashioned cold calls or walking in on a business and asking if they need any kind of website work, and you're usually targeting people that might look to build something with platforms like Wix. And then there's educational content, stuff like blogs that have titles where things say like Jamstack versus some technology, or straight up saying that Next.js is the best framework. So who is the Jamstack good for? They get a lot of clients that are maintaining marketing sites. They're the main ambassador of a brand, like a SaaS company, for example. Now, these sites have marketing teams focused on website promotion. And then there's also light e-commerce sites, clients that are already using something like Shopify on the back end and want a more personalized experience to set themselves apart from the competition. And then there's companies that have marketing teams that are a little more technical. Pro tip, these are marketing teams that are more likely to go Jamstack versus straight up software teams. And then there's also CIOs who may have heard about Next or the Jamstack. And so why is the Jamstack good for these categories, for marketing, e-commerce, and SaaS? So the benefits per site type. So with marketing, you want to talk to them and let them know that you're going to get great performance, security, everything's going to be cost effective, and an overall better developer experience. And for e-commerce, you get to use multiple backends. So for example, you can use Prisma for your content and Shopify for your products. And then there are SaaSes. So you get to share data across pages, shared payments. You can still use it as a single page. You still use the Jamstack as a single page app, and it's really easy to set up doc sites on the Jamstack. And just to be clear, every single category here, they all benefit from all the same things. These are more or less the things that you'd want to say, for the clients that are running these types of sites. So you found a good lead. What's next? So we asked these agencies, how do you pitch the Jamstack to clients? Now, selling the Jamstack isn't actually very special. If you can sell a website, you can sell a Jamstack website. And so, selling a website is more or less about faster growth, saving money, saving time. The thing is, Jamstack makes these things a lot easier. So what really makes Jamstack better? Well, out of the box, you get high performance because there's no background processing and data is served through an API. It's a lot easier to get fast websites without doing anything extra. Marketing teams are more likely to go Jamstack versus software teams. We said that earlier. They're secure by default. Static sites don't really require a constant connection to a server, meaning less chance for hackers to break your website. You don't have to worry about the guy in that GIF. They're easy to scale. Scalability allows them to grow. If they have hundreds or thousands of blog posts, products, or marketing pages, the Jamstack can handle it all. And they also work for every type of site. It doesn't matter if you have a marketing website, an e-commerce site, a SaaS, or something else, the Jamstack will work for you. And I'm sorry, I really tried to find a GIF for this one. I was really struggling. I wasted too much time on this slide. And then they also work with any platform. You're not really restricted by a single platform. Pick your front end, pick your back end. You're not locked into an ecosystem by your decisions. So one pro tip we got out of these interviews is that you should pitch design systems. So these are some screenshots provided by Dan on how Skyward pitches their projects. So static websites can still be dynamic. Skyward creates component-driven architecture starting with their designs. Building modular design means making edits, and it's much easier, and you're not restricted to just one layout. It also means developers don't have to guess what can and can't be edited. Working off modular designs means coding is much easier. Developers have been used to component-driven designs for a long time, but having designers and developers speaking the same language and thinking about components the same way makes collaboration between the teams a lot easier. And everything is documented and tested automatically. Storyblok is used to document components, creating a system where everyone can refer to and linking up designs and code. Chromatic is used to visually test the components based on Storyblok, ensuring components don't look different between pull requests. Cypress is used to functionally test components and make sure the user can interact with them as expected every time. You don't need this approach, but it does add a lot of value for just a little bit of extra effort. And so one thing Somos Gente shared is that they are able to build really fast. They don't actually pitch their design system directly to the clients, but because of the design system and the fact that it exists, allows them to say things that they can deliver a website in 2 weeks and promise that. And then from Roboto, clients, when they see the design system, they get to see what they're getting, how it's built, and they understand what they're paying for. It gives them a strong sense of security that supports conversions. And so Prismic slices, they help tremendously with putting together fluid design systems that are easy to present to both technical and non-technical clients. And then you also would benefit from demoing how easy it is to use Prismic. Not any of the agencies that I've interviewed, but a while ago I heard someone say to a client that, if you can write an email, then you can use Prismic. And I thought that was really helpful. So at the end of the day, this here is a list of things that are really important, like the valuable parts of the Jamstack. You want to figure out which one of these things resonate with your clients the most. So just to read it off, you've got high performance, low maintenance, it's secure by default, easy to scale, works for any type of website, works with any platform, and you can consume multiple content sources, and it's cost effective long term. And just to share a little story about the flexibility of multiple content sources, I believe it was Jelly Pepper. They had a client that wanted to move to the Jamstack. However, their old platform had over 300 blog posts, and they wanted to maintain that SEO value. So what would you do in that situation? Well, what Jelly Pepper did, they kept their current backend as the source of data while upgrading the front end to the Jamstack. So they got the performance boost, they maintained the SEO and all that other good stuff. They later moved everything over to Prismic when the client was ready. So one might ask, is Jamstack cost effective? Well, short term, if you're building a website from scratch and you're getting started with the Jamstack, it'll be quicker and easier if you're using a template. If not, you might find that traditional solutions currently offer faster ways to get up and running. But long term, Jamstack makes a lot of headaches simple for the long term. Maintenance, expansion, automation, testing, reusability. This leads to reduced costs and creates a better experience for you and other developers on the project. So let's talk about getting the work done. So we're talking about planning, building, and the maintenance. So with planning, you want to organize what you'll be doing and break it down into different parts. If you're working with a team, you can overlap, like working on design and development to be even more effective. And then you just straight up build, you get the designs done, the content, the development, any other parts of the process that you need to get out of the way. And then maintenance kind of looks like answering questions, fixing bugs if you get any of those. Like I haven't seen any bugs or anything. So, and then like other like ongoing support. I think it's Somos Gente. They like to say always answer the phone. I'd throw that under the maintenance category. And so what's different compared to traditional builds? So the process doesn't change much, but there are some small things you might find different. If you're used to building with drag and drop editors, you'll find less of that in the Jamstack space, at least for now. But instead, you get a better experience for your developers, making growing easier and more fun to work with. Projects also require less maintenance after the project is completed, which is great for clients as they aren't held hostage to keep their website up and running, which saves money long term and allows them to spend it effectively on improvements that actually matter. So what to do after project completion? So we've got these categories here: maintenance and support. Jamstack sites don't need maintenance to keep running, unlike traditional sites. But if you'd like to offer maintenance, it's a great way of getting more continued work. You can dedicate support time to improvements, which are a better value for your clients anyway. Dan shared one of their favorites: analytics reporting, bug fixing, and improving marketing over time with new landing pages or slices to improve page content. You can also suggest more improvements. If your client has a huge piece of software, there will probably be more areas which you can help them improve. Do a great job, and it'll be easy to convince them to keep working with you for other projects. And you'll be in a unique position where you already have inside knowledge about their projects. Another thing you might want to do is you want to get more testimonials and referrals. Work brings more work, so when a project is coming to an end, be sure to get testimonials from your client and that you can use in future pitches or on your website. Clients are also a great way of finding other clients. They have connections they work with, so ask them to refer you to others and an easy in for more work. And marketing. Marketing is the core of getting work done for every business. So when you have some downtime, it's a good time to start creating some newsletters, get on social media, start tweeting, reach out to others, and you can find your next project that way. So at the end of the day, what you're really selling to your clients is the future of the web. Jamstack is modular. It's designed to have parts swapped in and out to best suit your needs. You want an e-commerce store? Add Shopify. You want to accept Stripe payments? Add that too. You can do it all without changing your original stack. Jamstack is powerful. You're not losing any potential by switching to the Jamstack. You get better performance, better security, and better scalability out of the box. Jamstack is loved. Most developers who work with the Jamstack love it. Satisfaction is increasing, and more companies are switching to the Jamstack because of it. And just straight up, Jamstack is the future. And Prismic wants to help you find your future clients. We've actually built a free pitch deck template to help you land more clients. The link is prismic.club/Next.js Conf. Thank you, Vercel, for letting me give this talk. If you want to stay in touch, make sure you follow me on Twitter. Also follow Prismic. We're going to be diving deeper into these topics in the future. Bye.
Hi everyone, my name is Anuradha Kumari and I'm so excited to be presenting to you all today. Today I will be talking to you all about taking Next.js applications to next level with accessibility and SEO optimization. Before we start, little bit of introduction about myself. I'm working as a front-end consultant with passionate people. I'm a Google developers expert for web technologies and Cloudinary media developers expert, and also an accessibility advocate. You can reach out to me on Twitter at miracle_404. Let's get started. The agenda for today is I will be talking about some tips for creating accessible and SEO friendly Next.js applications. First, briefly see what these terms are. Accessibility means making resources and services usable by everyone. There are multiple types of disabilities in the world, and disabled people use different types of assistive technologies to access the web, like screen readers, switch, keyboards, etc. So we need to ensure that we follow proper coding guidelines so that we make our applications accessible to all our users. SEO or search engine optimization means making improvements in our application which might have noticeable impact in the way our website appears in the search results. To understand why we need SEO, let's see how the search engines like Google, Bing, etc. work. So the search engine or search system have four main responsibilities. They parse the content in all the websites available, and this is called the crawling phase. Then the data collected from crawling phase is stored for further access. It is called indexing. Sometimes they also go through the rendering phase where they perform some operations if the website has client-side JavaScript. Then comes the ranking, where the data stored in the indexes is queried as per user search inputs or keywords. Every search engine has a crawler, like Google has Googlebots. So, if you want to check if your website is indexed or not, you can go ahead and search in Google site colon your website name. So let's quickly check it out. Here I have tried to search for my website, which is anuradhakumari.com, and when I search for it, I can see all the URLs for my website, which is good. It means that my URLs are getting indexed by the Google. You can use this to check if your website is indexed or not. If not, it's time to make some SEO optimizations. Let's code. We can create a new Next.js application using yarn create next app application, and then we can run the dev server using yarn dev. So I have created a basic website here where I have made some changes to the default layout. Let us see how it looks. So I have a header which I am trying to create a game wherein to fight the inaccessibility, and then I have three different levels of games: lowest, medium, and highest. Now at this point, what I want to do is I want to run an audit and see how accessibility and SEO are doing in this stage. So you can right click on the website and inspect, then the DevTools will open up. In DevTools Lighthouse, what we can do that we can select for categories accessibility and SEO, go ahead and generate the report. The results are in. We can see that accessibility has a score of 97 and SEO has a score of 100. So if we see what is the error with accessibility, then it has a missing lang attribute on HTML. Before we go ahead and fix this, I would like to tell you that this score is not indicative of the total accessibility of your website. It is just some automated checks are run, and they contribute to almost 30 to 40% of accessibility issues. So we must also manually test our websites. So for this talk, we will stay with these Lighthouse reports. So let us go and see. So we ran the Lighthouse audit and we saw that there was a missing lang attribute on the HTML. Now, what is this error? So this is a very common error, and WebM, which is a non-profit organization, they every year run report accessibility checks on top 1 million website homepages. And in that report, if you see, there are like, this is the report, and almost 28.9% of home pages as of February 2021 had this missing document language error. There is also a very nice GitHub discussion around it on Vercel GitHub, where they talk about different ways in which we can solve this for our Next.js application. We are going to look at two of different approaches today. So how can we fix it? We can either add a custom document to our website, or we can add the locales in Next.js config. So let's start by using first approach, which is creating a custom document. So for that, we can go ahead and add a underscore document.js file in our pages folder. So I have created a document.js file in the pages folder, and this is the default code which I have taken from the Next.js website. And if we see, the main thing here is that we add the structure. So we have HTML head, body, tags here. Now we want to add the lang attribute to our HTML. So go ahead and add lang. So I would like to add language of English since my website is in English language. So if we go ahead and check this now, so in Elements tab, we can refresh the page and see that now the HTML contains the language of English. So now this will pass in the Lighthouse error report. So we saw how to add the lang to HTML using the custom document. We can also alternatively add a I18 configuration in Next.js config file, wherein we can add multiple locales. And then we can also add a default locale, and our HTML will pick this default locale. Now we added one single page and made it accessible. Now let's add more pages and see. So I have added 3 different folders because I have 3 different levels for this game. So lowest, medium, and highest. So, and I have added some code. So I have a section and a heading for it, and then a form where it different shows different questions. So let's see how it looks. So if we go to the lowest level, we see the list of questions which we can select from. So now we are interested again in running the Lighthouse report. So I will run it again. So the results are here, and if we see, the Lighthouse score again is 97. So we have a different error here now. The document does not have a title element. Why? Because we haven't added any title yet, but it is a very, very important piece of information. It is also important for accessibility as well as for SEOs, because the screen readers use it to make the users know that what your page is about, like what's the overview of your page. And also the search engine crawlers, they rely on it to determine if your page is relevant to the user search or not. So it's a very important information. And if we check for SEO errors, we can find the same title error. Apart from that, we also do not have yet added the meta description. It is also important because when your website appears in search results, it shows the summary of what your website is for. So, and it gives users a clear idea if they should really come and visit your website or not. So these are very important informations. So let us see how to fix that. Before that, there is one more thing which I noticed. When I created new pages, the default heading and footer is not coming. But what I want my pages to have header and footer, all of them, because they all represent a game together. So we can also manually add it on different pages, but we can also use something called a layout. So let us see. So first we will start by adding a layout. So what we can do, we can create a components folder with a layout file. So here I have created a components folder and a layout file. And here what we have done is the common header and footer, I have picked it and added it here. So we have a header and we have a footer. And also what I always want main on all my pages, right? So, and then there is this children. So whatever we will write now on all the pages, that content will come inside the children. We want it like this. So we will wrap all our pages within this layout component. So let's go ahead and do it. So we will start with our index.js file. So in index.js file, we will go ahead and remove this header and remove the main. We will add a layout to it. Then we'll remove the footer as well. And we add the layout. I remove the next footer. Okay. We do the same with our pages. So we will just see for lowest, and we go ahead and add the layout to it. So, okay. Let's go ahead and check the website again. So we see now we have this header and footer on this, and if you go to home page, it's still there. So now it's reusable and we can use it in all the pages that we want. So now let's fix the title and meta issues. For that, Next provides a head tag. So what we can do, that whatever title and meta description that we have to use, they go in the head tag and they will appear in the head of the HTML document. So I can add a title. So I will write the name of my game, that hey, this is it, and then I am on the lowest level page. So this gives the users an idea that where I am currently on their page, on the page. And now I can also add a meta here. So I have added a meta of description, so which will give an overall description of what my website, this website is about. Like it's the lowest level of game, and the questions are related to level conformance. So this will give overview to the users that what this web page will contain. Now if we go ahead again and if we see now, it displays the nice title. And if we run the Lighthouse report again, The scores are there, and if you can see, they are both 100 now because we have fixed all the issues which were listed. So we have added a layout so that the code does not get repeated, and also we have created added a title and meta description for new pages as well, so they also do well in search results. Now that we have seen some of these code examples, let us also see some of more important terms in SEO. So there is a robot.txt file. This file tells the search engine crawlers that which URLs the search engine crawlers can access on our websites. We can also use this to block some of the unimportant resource files like images, etc. So a sample of this is a sample code wherein if I want to block some pages, so like do not want Googlebot maybe to crawl my admin URL, so I can say that, hey, this is a user agent Googlebot and I would disallow this URL to be crawled by Googlebot. Otherwise, in other cases, we can just have that all different types of user agents and allowing all our URLs. And we can also add a link of sitemap, of our website sitemap, to this robot.txt files. Now, what is a sitemap? So sitemap is a file where we can provide information about our pages, videos, and other files on the website. It helps the search engines to find, crawl, index all of our website content, and it also tells the search engines which of our pages are more important. So we are going to see how we can create a sitemap.xml file for our website. Point to note here is sitemaps might not always be needed for SEO, but it's recommended and we can add it for our websites. So how can we generate a sitemap? We can also generate it manually. So we can create a sitemap.xml file in our public folder and generate it via some online generators or write code ourselves for all our URLs. But then we will have to update it every time we add new pages to it, like when there are new URLs. We can also use multiple automated solutions for it. I'm going to show you how we can use a package to do this. So there's this package called next-sitemap. So we can add it in def dependency in our code, and then we will have to create a sitemap.js file and add it in our post build script to say that after the build is finished, please go ahead and generate a sitemap for my websites. So let's see. So I've already added this package to my dev dependencies, and we can create a sitemap.js file with few information. It is very much configurable, but I have added the few necessary configurations here. First of them is site URL. So you should go and add the website where your code is deployed to this. So for example, I have deployed this code to fight-inaccessibility.vercel.app. So my website currently sits here. So I have added it to the site URL, and then we can say that, hey, please go ahead and generate a robot.txt file for me. And also we can optionally give it a size of sitemap. Now, when in package.json, I have a post build configuration. So in scripts, there is a post build script which says that go ahead and run the next sitemap with this configuration, which is present in our sitemap.js file. And I already ran it. So if we go to public, we see that robots and sitemap files are created. And if we take a look at what a sitemap XML file looks like, so it is a list of URLs of my website. So for example, this is the home, and then I had 3 different labels, so the 3 different URLs for it. So we have seen a way in which we can automatically generate our sitemap. Now that we have created our website and made it accessible and SEO friendly, so is our work done? Will we just wait for the search engines to rank our web page higher and wait for the users to search for keywords so that our websites appear in search results? So we do that, but we also share our links on social media so that users are aware of it. When you share your links on social media, how will the link look like in the social media preview, like on Twitter, LinkedIn? We have multiple ways in which we can check it, like Twitter has its own Twitter card validator, LinkedIn has a post inspector, Facebook also has one, and there is also a website which I really like because it gives you preview of all these websites together, which is meta tags preview. So far, whatever we have coded, let us see how it will appear when we will share it in the social media. So the code is deployed here. So the code till now is deployed at this link. So I will go to metatags.io and try to check how it looks. So if we see it gives the title and the description and the link of this website, but there is nothing to preview in the image. So it's not a very rich experience for users. They will just see a text and a link. So it might not interest the users much and they might not click on it. So how can we fix it? So there is something called an open graph. Open Graph is an internet protocol which enables any web page to become a rich object in a social graph. So when we are sharing any link, we can also customize it to contain rich information like title, image, URL, description, types, etc. So title, image, URL and types, these are recommended mandatory things which we must add when we are adding open graph information to any web page. There are others also which are optional, but you can go ahead and add it for a more rich experience. How we can add it? We add it in meta tag itself. So we add the property name in property, and then we add the value of it in the content attribute of meta tags. So let's go ahead and add these few OZ values for our website. So here I am in my home page index.js, and if you see, there are these OZ values added. So the title corresponds to, it should be very similar to the title of your website, and description, same goes for description. Then you can add a customized image here. So this image will appear when your website is shared on social media. So this is a very nice thing which we can do, and we can also add the URL where it is hosted. So with this code, let us see how it looks now in the social media preview. So this is deployed, this code is deployed on our main website, which is fightinnaccessibility.vercel.app. And if we search for it, I have added a custom image to it. It does not look very beautiful, but I mean, this is just to show you. But so it will look like this. You will see a good image, and then the title which you add in the open graph, and the description. So it's a good way to engage the users and let them know a preview of what they might expect on your content, and it provides a very rich user experience. We just saw how we can use open graphs to enhance the social media sharing of our website links. Let us conclude now with some takeaways. Always add a document language and set title for every page so that the screen readers as well as the search engine crawlers know what to expect on the page, and user knows what exactly is on that page. We also saw how to create robot.txt file and sitemap.xml. Then we saw how we can add open graph via meta tags in the head. I have added few links for the further read. These are very nice links, and we also have a Learn SEO tutorial on our Next.js website. So go ahead, give it a spin and see. All the resources for today's talk will be present at the website anuradhakumari.com/talks. You can also scan the QR code and get quick access to this website. It was very nice presenting to you all here. I hope it was helpful. Thank you and have a great day. Bye.
Hey guys, my name is Shadid and I love Next.js. I'm a developer advocate at Fauna, the serverless database. And today I'm going to show you guys how to build a GraphQL API with Next and Vercel. All right, so why would you want to build a GraphQL API with Next? Suppose you have a React or Next application and you're interacting with many small microservices and third-party data sources. So at this point, you might want to consider combining these into a single GraphQL service. Doing so will reduce complexity in your client-side code. You can build a GraphQL service inside your Next API layer. That way, you don't have to create and maintain an entirely new application. your GraphQL code will live in the same repository as your Next client code, making it easier to develop Conf modules and share code in between these two services. Now, finally, when you deploy your Next application to Vercel, it turns your GraphQL API into a serverless function. Now, that is powerful. You don't have to deal with scaling your application, and it will auto-scale. You don't really have to care about maintaining servers for your GraphQL API. It will be completely serverless. So that's interesting. All right, so we're going to build on simple GraphQL API using Next and Vercel. So stay tuned and let's jump into the code. All right, so here we are in our terminal. And the first thing we are going to do is to create our new Next application. So I'm just going to use create Next app. So npx create Next app. And my app name, I'm just going to call it my app. And wait for it to scaffold our application. All right, so it's working. Okay, perfect. Now we can cd into our application and open it up on VS Code. All right, so what we're going to do is we're going to put our GraphQL into the API layer. So we're going to create a new file here called GraphQL.js. All right, before we can write any code, we need to install a couple dependencies. So let's jump back to our terminal. And we're going to install our dependencies. So npm I Apollo server micro and micro course --save. And we're installing the latest version of Apollo server micro. So this is going to install the new Apollo server, the Apollo 3. All right, so let's jump back to it. So the first thing we're going to do is we're going to import our dependencies. So let's import course from micro course, and then import GQL and Apollo server from Apollo server micro. All right, so next we can create our type defs actually. So let's create our type defs. So type defs equals GQL. Oops. And here, okay, so let's do some simple GraphQL model. So I'm just gonna call it, I'm just gonna make a type called book. So book will have title, and a book also has an author property. And then I'm just going to create a simple type to query all the books. We call it books, and book returns an array of, so books return an array of book. All right, so that's our type def. So next, let's create a resolver for this. Okay, so resolvers, and here query, and then books, and we can, okay, so we have to return something. All right, so let's so let's create a static array since we're not connected to a database. So we're just gonna create an array with some objects. Okay, so title, what are some good books? I'm just gonna use the one they have in Apollo website. Just some random books. All right, and title for the next book, City of Glass. All right, author. Okay, awesome. And let's just, oops, return books. Okay, perfect. All right, so we got that figured out. We got our resolver. Oh, okay, so let's also do our course. I'm not really using semicolons in this one. All right. Okay, so next, let's create our Apollo server. And we're gonna make a new Apollo server. And we're gonna put our type defs right there. And we're gonna put our resolvers right there. We can't do a context. Let's do a context. And context is just a function. And, well, we're not returning anything, but let's just do it anyways. And then we're gonna have introspection true. And you can also enable the playground. So playground true. All right. Okay. All right. So next, what we can do, we're gonna have our servers to start. So we're just gonna start. I can't spell today. Apollo server dot start. So we're defining a variable and we're putting the start function in there. Now we're going to see why we need to do that. It's because we need to wrap our Apollo server to cores, and that's like the only way to make the Apollo server micro and Apollo 3 to work with Next. All right, so we're gonna do export default and we're gonna wrap the whole export into the course function, and that's why we bought in course the micro course. All right, so here we can create an async function, and it takes a request and a response, just like a normal Next.js API layer function handler, API handler. And then what we can do, we can check if the request method is equals option or not, because we only want to process post requests technically. So if it is, then end the request here, return false. If not, move on, and then await the Apollo server to start. Oh, I don't think we need, yeah, since we already defined it like that, so we don't really need to put the parentheses there. And then await Apollo server, create handler right there, and let's put our path, and this path has to match your API path. So we're going to go API/GraphQL. And we return our requests and response object. And that's about it. All right, let's save it. And let's try to run our application. Back in the terminal, let's try to run our application with npm run dev. Okay, now let's visit in our browser. So we're gonna go to API/GraphQL. Aha, so looks like it's working. So let's try to query our server. And there is an error. All right, so let's try to figure out what went wrong. And aha, looks like we forgot to turn off the body parser from Next. Since we're using Apollo Server Micro, we don't need the body parser. So body parser, and call it false, set it to false. All right, so we run the application, and let's go back here. And okay, now it's working. Okay, so books, title, author, let's try to run it. And it's running, and it's working. Woohoo! All right. Okay, so we're back here in our code. So the next thing we're gonna do is we're gonna connect to a database and pull the book data from our database. To do so, we're gonna use our favorite database, Fauna. Okay, so let's hop back into my browser here, and we're gonna go to fauna.com. And to get started, it's completely free to get started. You know, you just have to sign up for an account, and you don't really need a credit card. So it's super simple. So I'm just gonna log into my Fauna dashboard, and I am going to create a new database. All right, so we gotta give our database a name. I'm just gonna call it bookstore2, because I already created a bookstore earlier. All right, and then you can select the region group, and this specifies where your data is located. So I'm gonna say classic, and create, and there you have it. So this is our database, and here we can create a new collection. So the collections are like the tables. If you're coming from an SQL background, a collection is a table. Yeah, so let's create a table called book, collection called book, and hit save. All right, and a new book collection is created. Now we can add a document to our collection, and as you can see, it's really easy to insert document. It just uses JavaScript syntax. So we can pretty much just copy these things and save them, and they'll show up. Let's create the other one. Save. There you go. We got both of our documents in there. Okay, so the next thing what we have to do, we have to install the FaunaDB driver. So let's install that. I can get rid of this, save it, go back to my terminal, install, we can say -- save, and let's wait for this to get installed. Okay, so we got our driver installed. Now what we need to do is we have to generate a new Fauna secret so that our client application, our Next.js application, can connect to our Fauna database. All right, so let's go ahead and do that. Okay, so I'm just gonna go back to my browser, And in my Fauna dashboard here, in my bookstore 2 database, we're gonna select security, and here I'm gonna select new key, and I'm gonna generate an admin level key. Now in production, you should never generate an admin level key. You should only use an admin key in your pipeline, in your CI/CD pipeline. So you can take a look at the Fauna blogs for some of the best practices that we have around authentication, keys, and securities, and so on and so forth. However, for this, there's a Fauna blog right there. Okay, so you can check this out, check this blog site out for best practices and whatnot. However, for this demo application, we're just gonna use the admin role. Okay, so let's generate a key. Let's name our key Next App, and I'm gonna hit save, and a new key is generated. So I'm just gonna copy this, go back to my code over here, and here we're gonna create a couple new environment variables. So we're gonna create a .env file, and we're gonna call it fauna secret, and copy paste that. Also for our local environment, we can create another one, env.local. Copy paste that there. All right. Okay, so let's hop back into our GraphQL.js file. Now, what we are going to do is we're going to create a new client for our Fauna. So we're going to create a new client to connect to the Fauna database and query some data from there. To do so, we first need to import the client from Fauna. And then we create a new client. So we just create const client, new client. And here we're going to have to pass in the secret. And this is the secret that we just created. So process.env.fauna secret, and the domain. And the domain can be db.fauna.com. There you go. And now, using the client, we are going to query the database. Now, here in our resolver, we can just get rid of this. Create an async function. There you go. All right. Okay, so const response. We're gonna say await client dot query, and inside this query function we put our query. To interact with Fauna, we use a query language called Fauna Query Language, or FQL in short. It is very similar to JavaScript and based on a functional programming paradigm. It allows for complex, precise manipulation and retrieval of data stored within Fauna. Okay, so let's take a look at how we can use FQL to query our database. By the way, if you want to learn more about FQL, just visit the official documentation site for Fauna. And a good place to start learning FQL would be the FQL cheat sheet. So take a look at that as well. Okay, so back here in the code, and I just realized there is a typo in here. So it's not going to be FaunaDB, it's just going to be Fauna. All right, so let's fix that. All right, so back here in the query, let's write our Fauna FQL query. So I'm going to use a map function and bring in this map function. All right, so a map function in Fauna is very similar to a JavaScript map function, the type of map function you use to simplify your arrays. All right, so within the map function, we're going to use the paginate function. So this will paginate the list of documents that we get back from Fauna. And then we're going to use documents, and we're going to use the documents function from Fauna library. and collection and name of the collection. Okay, so let's bring in the collection here as well. All right. Okay, looking good. And then finally, we're gonna use a lambda function. And by the way, lambdas are similar. Lambdas are pretty much like the arrow functions in FQL. And we're gonna use the lambda function just to define like whatever we're getting back from the paginate function and to return it. And we also use a get function to get the data from there. All right, so let's console log this. Okay, so this here is pretty much your FQL query. Okay, all right, so let's test this out. So let's go back to our browser. Let's query this and return null. And we can see that our console log, it is returning some data. So let's map this data and return them as an array. Okay, so here, what I can do, let's define a new variable and response.data.map item, and we are going to get the item.data back. Okay, and return return the books. We don't really need that. We don't also need this anymore. So let's save and try it here. And there you go. Now we're getting the data from the database. Awesome. Okay. So next, let's deploy our application. Okay, now let's go ahead and deploy our application. And the easiest way to deploy the application is through Vercel CLI. So I'm gonna npx Vercel --prod. It's going to deploy prod, and depending on your internet speed, it's gonna take a few minutes or a few seconds. All right. Deploying, you're gonna get a URL. So I can just go to the URL. It's done deploying. So I can go API GraphQL. It takes me back here. Okay, so I can just copy this URL, come back to my Apollo Studio, and run a query just to test everything is working. And there you go. Everything is working as expected. Now, I can also go to vercel.com and I can kind of take a look at my logs. And if I go to function logs, and this is our GraphQL API. It turned it into a serverless function. Hey, I hope you enjoyed that video. If you have any feedback or if you just want to say hi, feel free to do so. My social media links should be in the description below. And other than that, I will see you next time, and have a good day.
Hello, Next.js audience. Welcome to this great session where we're going to talk about unlocking composable commerce with Next.js. We've got great content lined up for you. We're going to talk about the good, the great, and the ugly of doing headless implementations. We're going to talk a lot about composable commerce, and the definition of composable commerce for us is really revolves around greater flexibility. It's all about creating differentiated shopping experiences anywhere with a powerful commerce engine on the back end. From a quick introduction standpoint, my name is Sachin Wadhawan. I'm the Vice President of Technology Partnerships here at BigCommerce. I oversee our B2B, headless, and back office strategy, partner strategy for BigCommerce here. And very excited to have my co-presenter here, George, joining us. George, please introduce yourself as well.
Great, thanks, Sachin. Yes, I'm George Fitzgibbons. I'm a senior sales engineer here at BigCommerce. I get the opportunity to work with our prospects from a technical perspective, but also operational. So get really in the weeds as far as making sure things work for everybody, developers, business, marketing, all included.
Awesome. All right, so from an agenda standpoint, we're keeping it very simple. We're going to talk very quickly about industry trends. I'm going to give a quick overview of the open SaaS platform and what that means to us. We're going to go into some good, great, and the ugly, and then I'm going to pass it over to George, who's going to talk about value of open SaaS for developers and also do a Next.js demonstration. I think that's the part you guys are going to be most excited about. All right, so starting with pretty slides, and all I want you to take away from this research that was done by IDC is that the non-headless implementations are declining, and they're going to continue to decline over the next couple of years. And what's been gaining traction is really the hybrid headless platforms that offer both the out-of-the-box front-end functionality as well as freedom of choice on how you want to build your headless stores. In contrast to that, what Gartner has been saying, that by 2023, Gartner predicts that organizations will have adopted a composable approach, which will outpace competition by 80% in the speed of new feature implementation. So we're definitely seeing the industry kind of going in that headless commerce space. Now, we all know that monolith platforms have been declining and being replaced by modular solutions. And what these modular solutions are providing are fast performance, flexible capabilities. They're suited for any digital channel. They're more open, and we'll talk a lot about open SaaS. They're very focused on experience versus consumer experience versus product experience. They're cost effective. And of course, they are leveraging the microservices architecture, and we'll talk about that as well. Now, when you think about e-commerce technology spectrum, right, you've got open source on left-hand side. So think about Magentos of the world, where it's custom, it's on-premise, it tends to provide you the most flexibility. On the right-hand side, you've got cloud-based solutions, SaaS solutions, so think Shopify's of the like, that can tend to be restricted in what you can do with that platform or not. Think about BigCommerce sits right in the center there, and we coined that term open SaaS. So you get advantages of both open source and cloud-based. Now, peeling the onion a little bit furthermore, when you think about what is this headless commerce platform or open SaaS platform, of course, you've got the presentation layer at the top, right? This is where you're going to build those Next.js storefronts and create the amazing, beautiful, compelling user experiences from the front end. But then you've got the core commerce capabilities, right? And this is where the complexity of commerce comes in around merchandising and promotions, around product catalog, around data management, customer management, cart and checkout management. And to add on top of that, this platform also needs to integrate with other systems that the business or the merchant that you're working with might be using, like ERPs or order management systems or PIMs, right? If you peel the layer even further, right, you've got even more complexity in each of these commerce domains. So within product catalog, you've got price lists, you've got brands that you've got to figure out. Within payments and tax, you've got tax classes and you've got tax providers. All of this complexity, when you're leveraging a open SaaS platform, all of this complexity is something that you don't have to deal with as a developer while you're building and growing and managing the front end layer. Now, you want to make sure that the open SaaS platform also is leveraging modern SaaS structure, right? So it's built with growth in mind, it's built with scale in mind. So as your implementations and your customers continue to grow in their growth journey, they can continue to stay on that platform. Now, we truly believe in Mark architecture. We are part of a member of the Mark Alliance. And as you can see on the screen, many of the other players in this market that have also joined the Mark Alliance. So it's a great movement towards bringing success towards headless implementations. All right, so let's dive into the good, the great, and the ugly. On the good side, I've already talked about open SaaS, right? Some of the bullet points under open SaaS, the benefits of open SaaS that you as the developer community and the Next.js community can expect are lower total cost of ownership for your merchants and for you. You don't have to worry about upgrades and availability. So the platform scales, easy to upgrade. There are no disadvantages or hassles around maintenance of the platform. We take care of all of that. And then on top of that, you get 24/7 global customer support. Of course, the platform needs to be scalable. That's the good part. And as developers, we need to make sure that as you are customizing and creating unique feature set on behalf of your customers, you want to ensure that your platform scales and it's flexible and nimble to support those capabilities. You want to make sure that the open SaaS platform comes with comprehensive partner ecosystem, right? It should have pre-built integration so you don't have to. It should have best-in-class choices for your merchants in every category, right? So the platform should not force your customers or your merchants to pick one solution only, right? It should provide that freedom of choice. And then it should also enable easy upgrade path for the installed apps. So from a merchant experience, when they do add those add-on solutions to their store, right, it should be easy for them to leverage new features from those app solutions that are relevant to that customer, right? You also want to make sure your open SaaS platform is innovative, right? And it's keeping up and staying on top of the latest innovation. So again, you don't have to, right? So think about omni-channel. So how are businesses selling through TikTok, through Facebook, through Instagram? You want to make sure that the platform supports that. What about buy now, pay later? What about buy online, pick up in store? What about 3D AR, VR? How about SMS marketing, which is getting a lot of traction, right? So this is the good part of having an open SaaS platform, that the platform is ensuring that it offers features and capabilities in all the latest and greatest innovation. Now, payments gets complex really fast, right? So think about, does the platform provide the flexibility of the payment gateway, the payment methods, the payment types that you want integrations to? So think about Stripe, think about Chase, think about Klarna, right? The platform already should have those integrations pre-baked in, so you don't have to worry about how does your store enable these payment gateways, right? Similarly, I talked about omni-channel. So what if your customers and merchants want to list their products on Wish, on Walmart, on Amazon? Do you have to worry about how to create and integrate into those channels? Or the good part is that you should rely on your open SaaS platform to already have those integrations built in and maintained over time. Now, I talked about a few of the partner ecosystem, but this is just a quick flash of the most common, categories where these app solutions are going to be really relevant, right? So we already talked about payments, but think about shipping, think about fraud, think about email marketing, point of sale. And you can see, hopefully you recognize best-in-class solutions available here that are instantly available to you from the open SaaS commerce platform. All right, on the great part, wouldn't it be nice if this great platform was also developer-led? Wouldn't it be nice if it offered unlimited APIs? Wouldn't it be nice if it offered really fast site performance and had globalization capabilities in case you need to build stores in different languages and different currencies? And wouldn't it be nice if it just came mobile optimized out of the box, right? So these are all the benefits that make even that open SaaS strategy and vision, greater especially for the developer community. Now on the ugly side, right? So 3 categories that we see, and the reason we're calling it ugly, it's really, these are some of the areas where we see that our agencies and our developer community kind of get stuck, or these are the gotchas, right? So when you're doing a headless build, from a payment security standpoint, you've got to think about PCI compliance. Are you going to manage that? Or is the merchant going to own PCI compliance, right? As your business grows and you're getting more phishing and DDoS attacks, who manages that, right? Do you need global payment support? If you're launching into different countries, do you have the relationship with the banking companies and banking institutions in that region, in that country, to be able to support multi-currency? What about digital wallets? What if your customers want you to enable Apple Pay or Chase Pay on their stores? How easy it is for you to do that, and how do you do that, right? From a marketing side, right, you can create amazing, beautiful, compelling storefronts, but what happens to those visitors that you attract? How do they convert into paid customers, right? Discounts and promotions can get very complicated. You need segmentation and you need notification emails to be able to manage that, right? I talked a lot about integrations. You've got single-click apps that we looked at. You want to make sure that you are not having to work with each of those app providers to build a custom one-click, single-click, integration. As you start to put all the pieces together, data gets complex, right? Who has to deal with transforming the data and managing the sync between different data sources? And last but not least, of course, are your stores Google optimized, right, from an AMP perspective, right? So these are all some of the most common scenarios we have seen where the developers can tend to get stuck or have challenges as they're doing headless implementations. So with that, I'm going to pass it over to George to talk about value of open SaaS for developers.
Great, thanks, Sachin. So before we get into the nitty-gritty of this list, I generally have this same conversation when I'm talking about open SaaS to an engineering team. How I describe it is, anybody could connect to a tax provider, but does any engineer want to work with taxes? I don't know if there's any tax specialists out here, but those are the kind of tasks where it needs to get done, but there isn't necessarily a gain for the business. And so when we're talking about open SaaS, we're talking about the flexibility, but also the SaaS perspective. And when I'm thinking about SaaS, I'm thinking plug and play. There's more than a handful of best-in-class tax providers that are keeping up with all the newest laws. North Dakota changes, the tax providers keep up to date. Being able to plug and play and have that connected to your cart and checkout out of the box in a task that your engineering team doesn't have to worry about is really the power and beauty of open SaaS. So really to start getting into it a bit more, and we're going to walk through all these in some tangible examples, but our theory is adding out-of-the-box capabilities and functionality to best-in-class APIs and documentations is really taking the idea of headless and decoupled front ends to the next level. Taking it so you are able to focus on core business and executing on commerce with flexible, easy-to-use core functionality. So with powerful APIs, everything can be built, but not everything needs to be built. You don't necessarily need to own taxes. You don't necessarily need to own shipping. You don't necessarily need to own checkout. Those are just a couple examples. BigCommerce offers a robust admin. So when that marketing team wants to run a promotion and you tell them you need to write a script, you're not going to, alienate business and developers. You're going to really unite in giving them the tools they need, but also you're going to have everything you need from an API developer's perspective. So the combination of the two. Checkouts is a great example for us. Checkouts can be hard. We have over 70,000 merchants using our checkout. We've gone ahead and open sourced that checkout, so you can bring that wherever you want. Whether you host it with us and we take on full PCI compliance, or you need to heavily customize it and do whatever you want with it, that is a resource that we're giving to the community that you can take advantage of. And by the way, it's tied in with our taxes, tied in with shipping, and really easy to customize. And we'll go through that. And so at the end of the day, when we're talking about open SaaS, own what you need to own. Whatever is core to your business, your unique problems, your unique solutions that you as engineers solve, those are great. That's what makes the business special and what brings value. But the core commerce is a solved problem. We have solutions, we have domain expertise, and we can bring that to the table so that, again, you can focus on your business problems and we can take care of the commerce problems. So I'm going to hop into a couple demo examples now. I'm going to take the screen from you, Sachin. So quickly, just to orient before we start jumping all around, what we really focused around in this problem statement is somewhat of a common problem, and a problem where business and engineering need to solve. It's an example of subscriptions. Subscriptions are something that is core to businesses. Selling products is more in the commerce front. I'll give you an example. You need to list products. You need to merchandise the products. You need to set prices, organize, change orders of products. You need to add in promotions. But at the end of the day, somebody's buying a product. Once that product is bought, that's where core logic or core business rules come into play with subscriptions, i.e., how am I enrolling the user? How am I handling it once a user buys, say, a physical product and a subscription product, and all the complexity that can come with subscriptions? In the general example, anything that comes into play with unique business logic. So I'm in the back end of big commerce. And so this is really a SaaS component. So the analogy that I was given earlier, again, as a developer, you don't want to get into building out UIs of how you set up products. You want to give tools for the right job. Business users are able to come in here, set up products, build out kits, build out bundles, all those core commerce things that you see across the web. Very common. We've solved that. They're all baked into an easy-use admin. And so when we're talking about Next.js and the front end, just to call out, generally BigCommerce is front-end agnostic. We call them storefronts. You can have multiple storefronts, i.e. what we describe as channels. So in this example, we're really going to blend in the open and beauty of Next.js and the great framework with the SaaS in this example. So just walking through this site, it's very basic. Just to call out, we have a basic subscription product. Razors, could be food, could be perishable goods. You know, any of those common examples of refill products that are getting automated weekly. They may have different delivery dates. You know, all the complexity that can come with adding a subscription and maintaining that subscription. But from this simple example, I have this Next.js framework powering it all via the BigCommerce backend. When I'm going to interact with the cart and checkout, this falls back into the SaaS domain. Things like taxes, things like shipping, things like promotions can all be set up and enabled via the admin and respected by the API. And really where some of the more magic comes in is when you're going to a checkout. I always call this out. When you're talking headless, checkout is a big thing to always think about, because again, you can build anything you want with APIs, but checkouts you of course can build, but there's compliance and security risks that come with that. So by us bringing a checkout to the table can add a ton of value. You can really focus on that next front end, that user experience, but at the end of the day, you're having a fully optimized checkout. And just to call out, check out our GitHub, our checkout's there, and that's what I'm going to be leveraging in the example. As I said, we can host it, or you can take this and host it wherever you want, and of course, fully customize this. But taking that step to check out, what we'll see is going from the next framework to hosted checkout. So I'm going to march through this checkout and call it a couple things. So first, BigCommerce can handle all the account creation. If you have your own identity management platform, you certainly support single sign-on and things like that. But again, it's another service that's out of the box you can take advantage of. From there, calling out mobile payments. I had the Google Pay. We'll talk about that in more detail. But core things, every checkout is going to need the ability to collect shipping. From there, shipping methods. Just to go back to the admin and show some of that functionality. So similar analogy to taxes. You, of course, could go out and connect to any shipping provider, get those rates returned, and really, own the entire checkout. But when you have the power of OpenSaaS, those are things you can just take care of in the back end. Think about setting up shipping zones, tying in carriers. Those are all turnkey functionality. You want to try new markets, try new carriers. You're not burdened by, okay, now I have to build that out. You can really take advantage of some of this stuff. And so I have free shipping. Going from there, billing is the other big call out. So I'm connected with Stripe, and Stripe is going to be really a call out in this flow, as I'm going to enroll myself in a starter package. $10 a month, I'm going to get Razor shipped to me. That's really a core business thing. Rules that you may want to layer in your own logic. Again, it's not necessarily affecting the front end. I'm able to set it up, use everything out of the box. I'm abstracting this out. And that's really where we're going to get into some of the Next.js examples too. And so I, for this sake, am just going to do the BitCommerce fake credit card. So similar to Stripe, BitCommerce is a fake credit card you can use. Instead of 4242, it's 41011. But I'm going to kick off this checkout. And so from here, we're going to transition to talking more in the weeds in the code. So what this site, the Next.js site, it's all running this Next.js boilerplate starter. So I have all my code, front end, back end, encapsulated in one directory. This has a huge advantage just from management. I have everything in one place. I can reuse components, reuse integrations, all in this centralized location. So again, what we're focusing on here is a use case of basic subscriptions. So I'm going to kick off the flow of, I have an order now. Within BigCommerce, our API is completely observable, meaning when an order happens, pass that downstream or pass that to my Next.js layer. In the Next.js layer, I'm going to do something with it. When I say we abstract, basically you're able to do whatever you want on the front end. Take advantage out of the box. Marketing can do their thing. You guys as developers can own that logic. And so one thing I really love about Next.js is the serverless functions. So I was a huge fan of serverless functions. When using them in Next.js, it really took them for a next level to me. I have my entire front end, my entire back end, as I was saying, encapsulated into this one layer where I can control everything. So when I kick off this order, I'm going to send the order to my Next.js function, and then I'm going to enroll this user in a subscription. So from there, I kick this off. There's a couple important callouts. So this may seem very subtle, but this is a very SaaS component. You may have scoped out a beautiful site. You may have scoped out all your business logic. But one thing that's always at the tail end of the list is notification emails. It's very subtle, but BigCommerce has a full notification system. Of course, you could use the AWS SQS, set up a notification triggers, all that. But we're talking about weeks or days of work just saving because it's out of the box. So I've kicked off that order, and now that order is getting pinged to my subscription layer. From there, just to call out a little bit of order operation about tangibly how something like this could work. Walking through the function, I'm getting order data. From there, what I'm going to do with it is I want to say, hey, BigCommerce, give me every information about the order. BigCommerce API gives you line level data. So this could be a great example of some orders are physical products one time, some are subscription. You're able to do essentially what we described as mixed carts. So in this basic example, I look and say, hey, are any of the products in the order subscription products? If they are, let's enroll them in a subscription. One big call out with our API in its openness is this idea of a transaction ID. So we take care of sending data to Stripe. And what I mean take care of it, that's another task that you can easily do in the dashboard. So whether you're switching from Stripe to Adyen to another payment gateway, or you have multiple payment gateways because you're in South America, you're in EMEA, you need to manage all those different currencies with different payment gateways. Again, easy to set up. We have over 70 pre-integrated payment gateways. But in the example of Stripe, really the task is as simple as connecting with your Stripe account. From there, you have the granular settings. I turned on Google Pay, really easy to turn on. One thing that you're going to want to do if you're doing a flow like subscriptions is you're going to want to store the credit card. We are not storing credit cards. We're storing it with Stripe, handling that very securely with the payment tokens. So all that work that would go into building out a direct integration or even using Stripe elements, you've taken a smallish, medium developer task and turned it into a couple pushes of a button. So really the advantage of turning Stripe on, vaulting credit cards, when I want to interact with that, we aren't closing it off. You are still able to get to your transaction ID that Stripe generates. That's going to be key if you want to do anything with the transaction after it happens. In this case, we're going to give you the transaction ID back. And what you're going to then do is, okay, let me get that information about the customer and the payment method from Stripe. And from there, now I have everything I need to say, enter this user into my standard subscription. You can pass in more granular information of, oh, he signed up for a free box for the first time. So don't charge the first month, charge starting next month. Stripe has a great flexible API. Again, you're able to take advantage of Stripe's flexibility, our flexibility, and our openness. We aren't a closed ecosystem. Just because you use our checkout doesn't mean you can't access the data. You can. And that really gets to the idea of you're able to own your business logic. So at the end of the day, all within this same Next.js layer, I have the ability to build my own front end, interact with all the data, give business users a powerful admin. But when it comes time to, okay, BigCommerce, you powered all my core needs as far as selling, but I'm going to take over. And that's really this API layer of, okay, subscriptions is core to me, so I'm going to take over. Great. We'll give you all everything you need. User gets enrolled. And at the end of the day, you're managing with the best in breed tools. Tools like Stripe, BigCommerce, merge together to give developers powerful out-of-the-box tooling, just enough structure so you're not rebuilding everything. You have guardrails, but a ton of flexibility. You're not sacrificing anything by getting SaaS value.
Awesome. That was great, George. Thank you so much for the demonstration. Again, our goal here was really to give you an overview of the open SaaS commerce platform. And if this content piqued your interest, you have to go nowhere other than Next.js site. We've got a starter kit with Vercel. Go check it out. Try us out. Start a trial. Play around with Vercel, Next, and BigCommerce. And if you have questions, reach out to us. Yep. Thanks for joining us. Have a great rest of the conference. Bye, everyone.
E-commerce is driving one of the largest and fastest global economic transformations in human history. BigCommerce is a software as a service platform that powers 60,000 of the world's most interesting and beautiful e-commerce stores. We provide everything that a business needs to create, manage, and grow an online store. From the design of that store to the infusion of product catalog, the checkout, and all of the tools that help you market and grow. Our mission ultimately is to help our customers turn their long-term digital transformation into competitive advantage.